coldest rain keeps me awake for the golden days. I'm not afraid, I don't feel the pain. Lead me to the golden gate. I fall right back into memories. Forgot about the past, I slowly drift away. Yet it never really is what it seems. Feels like I'm drowning in despair, knowing that you won't be there.
Hello, everyone, and welcome to the PAIR Symposium 2020. I'm Fernanda Viégas. I'm one of the hosts today. I'm a principal scientist at Google Research and one of the founders of Google PAIR, the People Plus AI Research Initiative. We're so excited that you are all here. We have a packed day today. I'm talking to you live from London today, but we actually have 3 sessions. If we could go to the next slide. Yes, so I am, as I said, talking to you from London, and we have an amazing panel that is going to start very soon on exploring boundary objects in technology. Afterwards, there will be a session in Boston at 10 a.m. East time, so local time, Boston time, on exploring objective functions as boundary objects. And then finally, we're going to wrap up the day with a session in Seattle on exploring participatory ML boundary objects in the field. So you may have noticed that we have a theme going on with boundary objects today, and we'll get to that. We'll explain what we mean by boundary objects. But before we do that, I'd like to tell you a little bit of our agenda, just a little bit of logistics. So today, we're going to do the introduction and welcome, which I'm doing right now. We're going to jump in a series of lightning talks from our 4 panelists in the panel I'm about to moderate. And right after their talks, we are going to come back live with all 5 of us, myself and the 4 panelists. I'm really looking forward to that conversation. And then afterwards, there is a little break. And then afterwards, there are a number of breakout sessions. These are sessions that are not going to be live streamed. They're supposed to be more intimate conversations, and people have signed up for those. We got way more folks signing up than we anticipated, so we apologized if you have tried to sign up for one of the breakout sessions, but you weren't able to. This is the first time we do a virtual symposium, so we're learning as we go along. Next, please. The other thing I wanted to say is that captions are going to be available throughout our event today, and you can get this URL. It's also listed in the YouTube live stream description. Okay, and with that, next, I just wanted to take a moment to acknowledge that we're definitely living through a unique time in history with COVID and the pandemic and everybody staying home and doing everything virtually like we are right now. So please, take breaks, take care of yourselves. We try to schedule the day today with a lot of breaks and times in between. Everything also, except for the breakout sessions, is being recorded. So, do what's best for you and go at your own rhythm. And with that, I'd like to pass the words to Kristen Conrad, my colleague at Google, who's going to talk to us about university relations.
Thank you so much, Fernanda. I appreciate it. Hi, everyone. Thank you so much for joining. I just wanted to take a moment and introduce university relations. As Fernanda mentioned, my name's Kristen Conrad. I'm a program manager on the Google University Relations team, and we have partnered with the organizers of this event to make this possible. I just wanted to take a brief moment to raise awareness about the additional opportunities to potentially partner with the Google University Relations team in the future. Just high level, what we do, we help enable academic collaborations for Google Research, manage and support the interface between academic research and research across Google, promote and support academic research in Google's areas of interest. And we do this for the general good and participating in the ecosystem of academic, industry, and government. We create research results and impacts that would not otherwise be possible and make the world a better place. This symposium and other research that you all do is a great example of this. And some of the results of that are papers, open source codes, data sets, supports of all researchers across Google. The next slide, please. I just wanted to also share a couple of the different programs that we have. We have a few external research funding opportunities, as well as scientific exchange and building the next generation of researchers. And all of this leads to, again, great outcomes such as papers, the data sets, teaching, and community building. The next slide, please. I just wanted to go into a little bit more detail. For example, the Research Scholar Program we have aims to support early career faculty who are pursuing research in fields relevant to Google. Our Award for Inclusion Research program is a global program which recognizes and supports the academic research in computing or technology of underrepresented populations, as well as our Visiting Researcher program. Googlers can do research with faculty and industry researchers. If any of these would match your needs, and I'd encourage you to reach out to one of the Google researchers that you have connections with, or myself. I have my information on the next slide. Please don't hesitate to reach out to me directly. We also have some resources on the PAIR website as well. So thank you again. Fernanda, back to you.
Thank you so much, Kristen, and thank you for the partnership on putting together the symposium. One of the things I wanted to just briefly touch on is the People Plus AI Research Initiative. Our mandate is to create human-centered AI and really to dig into human-centered research and design in human AI interaction. And we couldn't do this without an amazing team. And so if we go to the next slide, please. This is our team. This is PAIR, and it is a big collaboration through many different parts of Google, a very interdisciplinary team. I'm very proud of that. And actually, a team that exists on a number of places around the planet. So it's one of the other sort of superpowers that we have. It's just having a very international understanding and approach. So if we go to the next slide, what are the kinds of things that PAIR does? We basically think about ourselves as doing three main things. If we go to the next slide, the first thing we do is conduct and publish human AI interaction research. And this takes a number of formats, from academic papers to blog posts to explorable visualizations online, you name it. Next, we also create and launch open source tools and platforms to build AI responsibly. And one of the things that makes me very happy is that we build these tools and we use them ourselves at Google. And then we also open source and share them with the world, which I think is very important. And then finally, if we go to the next slide, we'd like to think that we help widen the circle of who can participate in the development and application of AI. One of the big platforms we have for doing that is both our PAIR Medium channel, but also the People Plus AI guidebook that you see here. This is a guidebook that was published over a year ago, and that is aimed at UXers and managers who are designing and shipping AI-enabled products. And so this is one of the places where we try to come up with very concrete guidelines for doing this kind of work responsibly. So next slide. Today is about boundary objects for participatory machine learning. We designed the whole day around this theme. And so you may be asking yourself, what do you mean by that? It's a bunch of words. So let's go to the next slide. What are boundary objects anyhow? So in this definition of boundary objects, we think about it, coming from sociology. A boundary object is information such as specimens, field notes, and maps used in different ways by different communities. The whole purpose of boundary objects is to bridge between different communities that may have different vocabularies and different understandings of the same either situation or technology or the impact of the technology. And this is something that has existed for many, many years. We believe that this is a very powerful way of thinking about bridges now in AI. There are many different kinds of stakeholders that should be involved in critically thinking and building AI and using it responsibly. And we believe that this notion of boundary objects is one of the very powerful ways we can frame the public debate, or we can make progress in how can we all come together and start speaking a little bit more of the same language. Technologists, engineers, designers, citizens, professionals, you name it. And so today's symposium is going to be devoted to this notion of boundary objects. And with that, I would like to go to the next slide. And as I said, my own session right now is going to be on exploring boundary objects in technology. And if we go to the next slide, I have the honor of speaking with 4 amazing speakers today. And so I want to very briefly introduce each one of them before we watch their presentations. So Charlotte Lee is Associate Professor of Human-Centered Design at the Human-Centered Design and Engineering at the University of Washington. Annelien Bredenoord is Professor of Ethics of Biomedical Innovation at the University Medical Center of Utrecht. And Catherine D'Ignazio is Assistant Professor of Urban Science and Planning at MIT. And finally, Nithya Sambasivan is Staff HCI Researcher at Google Research and one of our very own team members at PAIR. I'm very excited because each one of them brings a different perspective to this notion of boundary objects, as you will see in their talks. And before we move to their talks, can we go to the next slide, please? So as you watch the presentations, please share your questions on this URL here. We're going to be tallying up the questions, and hopefully we'll have time during the panel to ask some of those questions live. Okay, so with that, I think we are now ready to move on to the speakers' presentations.
Hi there, it's wonderful to be here today to talk to you about boundary objects and coordination for creativity and innovation. I've devoted a great deal of my career to the study of boundary objects, so it's really a pleasure to be here on a symposium on the topic. So I was asked to say a few words about how I got started in studying boundary objects. And it really started when I was doing my dissertation work at the University of California, Los Angeles, UCLA, where I was very inspired by the work of Susan Lee Starr here on the bottom right of the slide, and also the work of my advisor, Phil Agri, up on the top. Both of them were very interested in this notion of how to support people coordinating to get work done in more open-ended situations. And these are situations where people are often collaborating or coordinating to try to innovate, to come up with new knowledge or to come up with new ways of doing things. Both Phil and Lee were interested very much in distributed artificial intelligence. Phil was a product of the MIT AI lab, and as he studied AI, he became rather disillusioned with some of the narrow approaches that focused just on cognition to studying artificial intelligence. In doing my work, I started to get interested in Lee's work on boundary objects. Lee's notions of boundary objects were different from a lot of the other concepts being used at the time and even now. Looking at coordination, a lot of the theories were very, very tied to specific tasks and to specific activities. And Lee's concept of boundary objects was a little broader. She defined them as informational objects that are used by different communities for different purposes and a means of coordination between actors. And this was like a general enough concept that it could be applied everywhere, which is why this concept has been used in many, many different disciplines and cited thousands of times. So the concept of boundary objects Lee put forth was written across a few different papers. The work has been taken up by many, expanded by a few, including myself. And this expansion from the idea of boundary objects tends to take a certain character and flavor, where boundary objects were objects that were to satisfy the informational requirements of each community of practice or group or department and maintained a common identity across sites. So a lot of work, not just my own, on boundary negotiating artifacts sort of said, well, there's other kinds of objects that sit in between communities of practice, groups, departments, that don't necessarily satisfy all the information requirements, that don't have this common identity. And we were expanding to say, like, let's look at other kinds of objects and artifacts, I use those interchangeably, that are used for collaborative sense making, that are used to negotiate the boundary themselves. And so part of this was that we were looking at different kinds of objects that sit in between, but that we were also looking at different kinds of situations, ones that were a little more ambiguous, where maybe the outcome wasn't determined or the methods weren't really very set. So other ways to think about boundary objects and other ways that the notion of boundary objects have expanded is to think more about epistemic objects. They're technical objects that are ready to hand, that are complete and unproblematic. They tend to be fixed and stable. These are the ones that we wrote about the most in those early papers. The follow-on work, including this work by Ewenstein and White, talked a bit more about epistemic artifacts that are characterized by incompleteness, that they're partially expressed, they might have multiple instantiations, and they're continuously evolving. So you may think of like people collaborating around drawings, maybe they're sketching together, things that you would see in a brainstorming activity. And that these artifacts are often dynamic and able to enable knowledge. Now, it's really important to note that things aren't, just boundary, we don't have situations where it's just boundary objects and just boundary negotiating artifacts or just technical artifacts and just epistemic. But you should think of every collaboration having both of those kinds or multiple kinds. But as you go forth in a workflow, in a design project, you might go from having mostly epistemic objects to mostly technical artifacts. In a lot of the work that we've done thus far as technology developers, mostly we've been focused on technical artifacts because those are easier to instantiate, they're easier to see, they're a little more stable. But a lot of that work that we have to focus on going forward with boundary objects are ones where there are more epistemic objects and more epistemic work to be done. Complicated design projects, scientific research, things like that. So in thinking about these different types of design situations and these different types of artifacts, we also want to think about notions of power. And sometimes when I mention the notion of power to a computational audience, people feel a little uncomfortable because people tend to think of one aspect of power, which is this one on the lower right, this notion of power as domination. But there are other ways to think of power, other definitions. There's power as a resource, meaning something that some have and some don't have, that we want to redistribute or perhaps not, depending on who you are. And power as empowerment. And it's hard to talk about empowerment without also talking about domination. But newer notions about power, like Amy Allen's work on the power of feminist theory, is talking about power as something that's relational. That's something that is being negotiated. And so anytime you think of a set of relationships between people and between artifacts, where things are getting done, decisions are being made, where relationships are being cultivated, you have a situation where we are making decisions about power. We're enacting power. So when we're thinking about relationships, it's useful to think about the things that we build as cultivating relationships. So going back to Phil's work on computation and human experience, which he published in '97, but the work dates back from the late 80s. He talks a lot about algorithms having a social context, about embodied agents having background understanding. Like, I know things about a cultural situation. I know things about the background of the people involved, the history and the values of an organization. And so these need to be taken into account. And similarly, individuals are always creating themselves and their relationships. that these are things that shift and change over time. And so when he was talking about AI, and Lee was talking about AI in terms of distributed artificial intelligence, they're also saying, like, the intelligence, it exists in these communities of people, right? And how they interact and how they discover together and how they learn together. And so Phil talked about these ways forward for boundary objects and AI. And it's interesting because this work was laid out for us many years ago, but now many of us in, you know, CSCW and HCI and other fields are like coming back to this really important work and this really important thinking to look for ways forward. And Phil talked about embracing computation as being part of a history of ideas. If we think of every community as creating ideas and then being part of a history of ideas, to think about the things we create, boundary objects, a data repository, for example, could be a boundary object, or more specifically, a boundary negotiating artifact most of the time, if it's a living data repository. And we want to make transparent the underlying decisions and assumptions in the moment so that people understand the ramifications of their decisions and assumptions, so they can see what happens when they present a new boundary negotiating artifact. In my original research, looking at a community of museum exhibition developers, there was an immediacy to creating a boundary negotiating artifact. Like, oh, here's a sketch for a new idea. Let's sit around, let's draw on it, let's discuss it, let's fight about it, let's celebrate it. There is this immediate feedback from the design group and then later from the larger community where people could see how the decisions were being made, where people could question each other's assumptions. And that there's this ongoing inspection of premises and methods. It's not just, let's lock it down once and then keep it away from the community, that there's this commitment to this ongoing inspection, because there's an ongoing sense making, of creating new ways of doing things and new understandings. And again, we're looking at situations that are highly innovative, right? And so this is necessary for that process of innovation. So final thoughts about boundary objects. So objects that AI systems create can provoke and prevent different kinds of conversations. A lot of the ethnographic work that me and my colleagues have been doing are studying what kinds of conversations people have around which sets of boundary objects, which data repositories, which algorithms, which tools. And also this notion that different kinds of conversations implicate different kinds of boundary objects. A lot of the most interesting research we have to do has to do with these epistemic or boundary negotiating artifacts that are much harder to facilitate. How do you facilitate an opening of a design space? And that these different kinds of boundary objects facilitate different kinds of conversations. And part of our decision is to say, what kind of conversations do we want to encourage? And then thinking about how does it change the design space and our priorities when we think about the tools and systems we create as a communal project of sense-making. And not only a communal project of sense-making, but also precedent setting for who gets to have a say when about what and how. In creating tools and systems for coordination, we're already in the mix. We're having discussions about power. And so being mindful about the boundary objects that we're designing and using is really a very powerful way forward in terms of being thoughtful about the things that we produce and the effects that we have on the world. So I want to thank you for your attention today, and also thank my students who made all of this work and this presentation itself possible.
Hello, my name is Annelien Bredenoord and I would like to introduce myself through this short video. I'm sending this video from my home office in the beautiful city of Utrecht in the middle of the Netherlands. Due to the COVID situation in the Netherlands, we're really restricted in going to our offices. So most people are working many days from home, like me. I'm a bioethics professor at Utrecht University and the University Medical Center Utrecht, but I'm also a politician in the sense that I'm a member of Dutch Senate, Dutch First Chamber. And I should say that we have a bicameral system with a second chamber, and those people are directly elected and they are full-time politicians, and we usually say that the political primate is in the second chamber. But we also have a Senate, a first chamber, and in the Senate there are people like me, although most are a bit older. Senators are actually part-time, like it takes sometimes 10 hours a week, sometimes 20 hours, and we're there for the checks and balances, and we have a final look and a final say over legislation. So it's not primary, it's also political, but it's not primary political. It's primary to look at the quality of legislation. So we have people with different expertise, and so my expertise is in ethics, bioethics particularly, but also broader experience at academia and working in healthcare systems. And I'm interested both from a broader societal perspective, but also from an ethical perspective in emerging technologies. And this, of course, includes technologies such as artificial intelligence, but also reproductive technologies, genomics, genetics, developments in CRISPR-Cas, which means genome editing. I'm doing a lot of work in stem cell research, biobanking, and using data from patients in research. And I think one of the hallmarks of how I have a group, a research group at the University Medical Center in Utrecht, and I think the hallmark of what we are doing is called ethics parallel research. And actually it's a type of early ethics engagement in the development of emerging technologies. And obviously, as I'm particularly centered in a medical center and near a cell biology institute, the Hubrecht Institute, it's particularly focused at biomedical developments. And what we aim to realize with ethics parallel research is we would like to guide the development process of technologies in biomedicine, and we aim to provide input for the normative evaluation of such technologies. And we think there are at least 6 ingredients or elements of this type of ethics parallel research, and we're doing this both in practice, but we also theorized this approach as a way that professional ethicists like me can guide the development of new technologies that is sometimes sensitive or controversial. Well, the first element of this approach is what we call the disentangling of wicked problems. So many new technologies raise wicked problems. Think about genome editing, CRISPR-Cas, in which you can modify the germ cells of human embryos, which would mean that an embryo has a different collection of DNA compared where you can modify the DNA of human embryos. And for example, this is a wicked problem because first of all, whether to answer the question, is it safe, is it acceptable, you need many disciplines. It cannot be answered by one single discipline. And second, there is also disagreement about the preferred outcome. So it's a normative question in the sense, and there is political opponents and opposition about these kind of developments. So disentangling, unraveling these type of developments and trying to unravel the arguments, considerations, but also interest, that is a first step that we try to do in this ethics parallel research. And then I think the second element of our approach is what we call upstream or midstream ethical analysis. So I think many people have a prejudice about ethicists working in an ivory tower and telling too late and maybe also too little that a technology is not good for society or not good for people. We have a dramatically different approach because we work really upstream. So I go to international stem cell conferences, AI conferences, reproductive medicine conferences, and we try to start our ethical evaluation and ethical co-production in a very early stage, to become involved in a very early stage, also to show the developers and the researchers that their decisions are not only technical, but particularly also ethical, normative. So we are involved upstream and also midstream. Once the technology hits the ground, is introduced in, for example, a healthcare system, we are interested in what does it do with our perceptions, thoughts, does it affect normative concepts like justice. So, for example, we work together with the gynecology departments in our hospital. They developed a mobile app for women at risk of, pregnant women at risk of having pre-eclampsia with complications during pregnancy. And so we do a midstream ethical analysis. So once the app is introduced and people use these, pregnant women use the app from the homes, then we start our ethical evaluation and we interview the pregnant women, but also the nurses, the company that's developed the app, the gynecologist, etc. So we work in an early stage of development. Then the third element of this ethics parallel research is that we do ethics from within. And this means that we're not at a large distance from the technology, but we try to unfold our ethical evaluation from within. We work shoulder on shoulder with all the groups of people that I just mentioned. Then a fourth element of how ethics parallel research works is that it includes empirical research. So it's not only philosophy, not only analytical tools, but also empirical research. And then you can think about qualitative research, interviews, focus groups, but also quantitative questionnaires. For example, we did a large study asking patients with cancer whether they would be interested to, when their genome and their tumor would be sequenced genetically, whether they would be interested to hear unsolicited or incidental findings from their DNA sequencing. Then a fifth element is that we always try to involve some way of public participation, and this is because biomedical technologies and also developments in machine learning and the use of data, they not only affect patients or professionals like us, but they affect all people, all citizens involved, and they change how we work, how we have children, and how we also relax. So it's important also to involve the people who are impacted and use the technology. And then finally, we also map the societal impacts or the expected, anticipated societal impacts, and we try to include them in the ethical analysis. And well, in this way, we'd like to steer technology in the right direction. And so that is something that I do on a day-by-day basis. I think it's one of the best jobs you can imagine, and I think also the combination with being active both internationally but also in the political domain gives you really a comprehensive view of the interests, legislation and considerations that need to be made by responsible innovation. I look forward to seeing you all at the symposium.
Good morning. Thank you so much for inviting me to be part of this event. Today, I want to present about a boundary object called the counter data set. So to get started, we first need to introduce a recent book that I've co-authored together with Lauren Klein, who's a professor down at Emory University in Atlanta. So our book is called Data Feminism, and I'm going to describe a little bit about the motivation for writing the book and some of the principles that come out of it as a way of setting the scene for what we mean by the counter data set. So we see data feminism as part of a growing body of work that's holding corporate and government actors accountable for basically making racist, sexist, and classist data products. So these are things like face detection systems that cannot see women of color, hiring algorithms that demote women's resumes, search algorithms that circulate negative stereotypes about Black girls, all these things and more. And whereas, you know, the era of big data was sort of heralded by this meme that you see here out of The Economist, this idea of data as being the new oil. This is a kind of meme that we characterize as because it's traveled so far and so wide, and you can actually watch mashups of this on YouTube, many people saying this over and over and over again. And the metaphors are sort of apt. So if we think about the metaphors that we apply to extractive industries like oil, where we mine, we capture, we clean, we process, and so on. There's been a growing pushback against this kind of extractive industry notion of data, because like we know with oil, the actual profits that are reaped from such extractive industries tend to benefit the people who are using this metaphor in a kind of a positive way. And this pushback has been coming for maybe the past 5 years and really growing. And this is some of the work that you see on the bottom of the slide that has been inspirational to us as we have written our book. And largely this work the pushback is coming from Black and Indigenous women of color, from white women, from Indigenous people, immigrant communities, LGBTQ people, and more. And in very different ways and in different mediums, they say something like, data is the same old oppression. So in fact, instead of being liberated by our data sets and data systems and our algorithms, we are in fact accelerating and exacerbating existing inequalities in the world. And so what we bring to this conversation with our book is a focus on feminism and intersectional feminism in particular. So we like to be clear about what our definition of feminism is. So feminism is a belief in equal rights for all genders. It's organized activity to realize those rights. And it's also, and I think very excitingly, an intellectual heritage. And it's a heritage that has thought deeply about ethics and inequality. And one very important thing to note is that feminism in the year 2020 must be understood as being intersectional. So this is a term coined by Kimberly Crenshaw. And she uses this term to explain how social inequality cannot be explained by one dimension of difference. So we can't only be looking at sexism when we're looking at inequality. We have to talk about the intersection of many forces of oppression that produce it, meaning racism, classism, colonialism, and so on. And so this is an important takeaway because what this means is that intersectional feminism is not only about women. It's not even only about gender, it's about power, thinking about who has power and who does not have power. So our basic argument is that intersectional feminism can help challenge and change the unequal distribution of power that we currently see in data science in so many different ways that we both document in the book and that others have detailed. And in fact, if data science hopes to do what we call good in the world, it actually really needs an intersectional feminist perspective to do that. So the book has 7 principles. There's not really time to go into all of them in a short talk today, but this is more or less how the book is also structured. So we sort of take one principle per chapter and we try to introduce the feminist thinkers that sort of led to formulating this principle, as well as folks in the world who are using data in the service of realizing that principle. So trying to show that data feminism is something that can be done and is already being done by a variety of folks who are already doing things in the world. So I'm just going to talk about a couple examples and sort of pivot to this idea of the counter data set. So in the book, and this is right in the first chapter, when we're talking about examining power, we tell the story of Mimi Onwoha's efforts to collect what she calls missing data sets. And so she's an artist. And these missing data sets are basically just a list. These are data sets that a reasonable person may expect to exist. So things like the number of citizens killed by police, or the number of men versus women with cases of coronavirus. But these data sets don't exist. So Onwoha takes an analysis of power, this first principle of ours, in her art project, and she asks why. So why do we have detailed data on things like guinea pig teeth, but not police violence? While there's a lot of discussion about bias in data sets and algorithms, we also have to consider which data are not even collected in the first place due to systemic bias. So it's here where I want to introduce the idea that a boundary object for machine learning may be considered as being this counter data set. So in data feminism, we discuss counter data collection as activist data collection that challenges power, meaning it directly challenges racism, sexism, and so on. So counter data sets are collected outside of hegemonic mainstream counting institutions because their very purpose is to challenge those institutions to see, count, and value something or someone in the world differently. And just to say that when you start looking for counter data sets, you will start to find them everywhere. They're really proliferating in fields like data journalism, for example. And so one area that's very active in terms of counter data collection is COVID data, and specifically COVID data broken down by race, indigenous status, gender, and so on. But the example I want to focus on involves feminicide, and this is the gender-related killing of women and girls. So feminicide in Mexico and basically every other country in the world is another case of missing data sets. Feminicide is legally defined as a crime in 18 countries, including Mexico. And this is thanks to the strength of the Latin American feminist movement. But the state doesn't systematically collect data on the phenomenon, even though they have laws on the books about it. So because of that, this is the subject of emerging public anger in Latin America, because of the way that the state neglects to implement its own laws and provisions. So in the book, we tell the story of Maria Salguero, who she resolved to head straight towards that problem and collect the missing data herself. And she spends 2 to 4 hours a day logging feminicide on a Google map that she culls from media reports. So she has helped families locate loved ones, she's provided data to journalists and NGOs, and she's testified in front of Mexico's Congress multiple times. So in 2019, I was on sabbatical revising data feminism. I was living in Buenos Aires, Argentina, and I started meeting with folks working on the issue of feminicide. And it turns out that Maria Salguero is by no means the only person collecting counter data on feminicide. There are many activists, civil society organizations, and journalists, especially in Latin America, who are doing this work. And it was around this time that I started working with Silvana Fumega at the Latin American Initiative for Open Data and Elena Suarez of the group Feminicidio Uruguay. And so we've since gone on to undertake qualitative and participatory design research with a number of the groups who are doing this counter data collection work. And what's emerging from these interviews is that the counter data sets created by civil society groups and activists are engaged in a back and forth contestational dialogue with many different groups. For example, while feminicide data sets use information from media and government sources, they create alternative categorization and labeling schemes that challenge the framings and the bias in those mainstream reports. And civil society groups' definition of feminicide is often much broader than a legal definition of feminicide, which often limits it to intimate partner violence. And then likewise, families of murdered women serve as both a source of cases for the database, so they often contact activists directly, as well as a key group that activists support. So for example, some groups run programs for grieving families and help them take broader action on the topic and seek justice for their loved ones. And again, the broader social movements coalescing around the topic of gender-based killing serve as both a source for compiling feminicide cases, as well as a key social group that can be mobilized when there's a new case included in the database. So I'd like to leave you today is with the provocation that counter data sets represent a powerful boundary object when we think about participatory machine learning, precisely because they are challenging mainstream, hegemonic, oppressive definitions of a social phenomenon as it has either been described on the one hand or ignored on the other hand in these mainstream data sets. So counter data sets are arguing for bringing into being an alternate political reality, and they should be an important site of participatory design and computational allyship for technologists. Because if we choose to work only with existing data sets created by mainstream counting institutions, we are potentially perpetuating a status quo that is sexist, racist, elitist, and more. So if you're interested in this work, you can check out a series of events that we're organizing this month or email me for a copy of our recent conference paper. Thank you so much.
Hi, I'm Nithya Sambasivan. I'm an HCI researcher at Google Research, part of the PAIR team and the Google Research India Lab. And I'm here to talk to you today about data as a boundary object in the ML pipeline. So I'm representing the work of multiple Googlers and collaborators, including Kristen Olsen, Shivani Kapania, and other folks at Google. So data is the critical technical infrastructure of AI. Data largely determines performance, fairness, robustness, safety, and scalability of AI systems. Data sourcing and labeling is an estimated 25 to 60% OpEx cost of ML projects. Paradoxically, for AI researchers and developers, data is often the least incentivized aspect. It is viewed as operational relative to building new models and algorithms. Humans power the ML data pipeline, from data collectors to raters to domain experts to developers. But human experiences and challenges in ML are less understood. As models become more commoditized, AI is increasingly expanding into high-stakes domains where the safety aspect on living beings is high, such as in cancer diagnosis, wildlife detection, and credit assessment. It's not just about cat versus dog detection anymore. Data has often been attacked as a database systems issue, a legal issue, or a licensing issue, but we believe that human-computer interaction has an important role to play in improving ML data quality. So for the past year, we have conducted a systematic study of various actors in the ML data pipeline in multiple parts of the world. We've studied goals, values, practices, processes, and challenges around data of the various groups in the pipeline. Invoking Starr and Griesemer, we put forth that data is a boundary object in ML. It is robust, shared, and yet plastic enough where it is viewed differently along different value alignments by various groups along the pipeline. I will talk to you about this in more detail in a minute, but in brief, data collectors like frontline health workers who power many of the cutting-edge, high-stakes data sets see data as a tool for reporting and program delivery, data is often orthogonal to their services, sometimes a burden. Raters are measured by their data outputs, making data an economic artifact for them. AI developers use data as code for ML, which then gets implemented into systems that then impact society. So let me start with a key observation of ours, which is that of data cascades in AI. So we define data cascades as compounding events causing negative downstream effects from data issues that result in technical debt over time. In our study of AI developers' data practices in high-stakes AI, we observed prolific data cascades. 92% experienced at least one cascade. 45% experienced two or more cascades. And this is troubling because of the domains that are high stakes that we studied. Data cascades are opaque and largely invisible. They're triggered by conventional ML practices from worlds of big data and viewing data as grunt work. Cascades have negative impacts, including abandoning projects, redoing data collection, and causing user harm. However, in our study, the data cascades were avoidable with intentional processes and practices. So what are some factors causing these cascades? Incentives for novel model development over data rigor, limited data education in AI and ML, and the fact that it's sometimes difficult to create new data sets in cutting-edge AI, and developers often make do with what they can get here. I'll give you two examples of triggers for data cascades. In high-stakes domains, AI systems transition from well-defined and understood environments to brittle deployments closely interacting with the physical world. A conventional ML practice of creating pristine training data sets in development led to system failures in production. So even the smallest of artifacts like fingerprints, shadows, dust on the lens, improper lighting, and pen markings were reported to affect predictions. For example, in our study, a millimeter movement of a camera led to a road safety model failing in production. Another example of a cascade trigger is from the over-reliance on data sense making in social and scientific contexts by AI developers, where they may have lower application domain expertise and engaging poorly with the domain experts here. Questions like, is this a fracture? Is this a village resident or a poacher? Is this a sign of preeclampsia? Actually require domain expertise. Moving to data raters, we find that one of the key aspects of their experience, that is, the rater user interfaces and their tasks, are rather poorly designed. Many people can draw a bounding box, but as AI gets implemented in more complex and subjective domains, the gap between who labels the data and who consumes the AI predictions comes into sharper focus. Labeling can be made more accessible and representative by designing tasks that account for rater environments, time allotments, usability, and speaking the language of data collaborators. For example, rather than providing room for ambiguity, many UIs today appear to force raters into binary decisions, leading to poor and inaccurate labels. Another example is of how functionality for productivity, like undos to rectify mistakes, providing feedback on tasks, specificity of tasks, pilot testing, and so on, are rather uncommon today. But we need more of these. And finally, on data collectors, as AI enters domains that have been hard to cover for governments and civil society, like COVID tracking and flood forecasting, many data sets come from frontline workers who are a part of NGOs, government services, and field partners, like community health workers and microfinance staff. While the workers have pride and prestige in doing good work, data collection for ML is often a burden, coming in the way of their goals and workflows. For example, recording values every few minutes for a medical data set can mean that a patient receives less care. Frontline workers do the invisible work to power high-stakes ML, but they do not reap the benefits of ML capital. Instead, they are underpaid and ignored. Many ML projects in our study did not originally set out to create data literacy or transparency into ML use cases for the data workers. So how can we move to a more proactive focus on data that results in safer and robust systems for all, and one that is grounded in ethics? We call for a shift from doing more with data to doing better with data. We see the use of imperfect and inaccurate system metrics like F1 score used for data quality instead as a proxy, which often measure the wrong thing and are too late to detect and course correct data cascades. How might we develop better data quality metrics, better documentation, and better iterations in model development? How might we take into account the fragility of the real world where things can go wrong fast? We should move from a culture of fear among raters to viewing them as partners. We should make tasks and user interfaces more data worker-centric. How can data collectors benefit from ML revenue and prestige? Today, as it stands, there's an unfortunate lack of involvement and appreciation for application domain expertise in AI and ML. We need to incorporate domain expertise throughout the model development, not just in the problem formulation stage. We also see an opportunity for better tools for data. Several tools today focus on analysis, wrangling, and cleaning, but our research points to an opportunity to support the upstream work of defining dataset requirements and the downstream challenges of monitoring incoming live data, which can lead to data drifts, and measuring the impacts of data on society. We need better incentives for data rigor, including mainstream empiricism, rewarding data glue work in organizations, and reusability of data. Today, ML and data education seem to use toy data sets that are well labeled and West-centric, like US Census data, but we need to train practitioners and researchers more on sourcing, collecting, synthesizing, and labeling their own data sets, which is often a competitive advantage. Thank you.
Wow, hello, welcome back everyone. These were amazing presentations, giving us such different perspectives on the notion of boundary objects, the history of boundary objects, perspectives from data feminism, bioethics, HCI, sort of a lot of work in the field. So I'm very excited to welcome now our panelists, Charlotte, Catherine, Annelien, and Nithya. Please join me. Yay, we're all here. Welcome everyone. Thank you so much for participating in this panel. We are distributed across the world, and so I just wanna thank everyone because Annelien and myself are here in Europe, but the other panelists are in the US, and two of our panelists are on the west coast of the US, so it's 5 a.m. for them. So thank you for participating. All right, so I would love to start with a question for all of you. Can you think about an example, a concrete example of a powerful boundary object you've seen used in practice? And how has that use led to any change? It doesn't have to be AI related, but any boundary object you've seen used in practice, and what change has it created in the world? Anyone? Who would like to go first?
I'll go first. Yeah, so one of the projects that I worked on was a traffic management study for the city of Seattle and King County in the state of Washington. And we were in a group there trying to create a new, well, we're still working on it, a virtual command center for traffic management in the city, not just accidents, but all of the traffic. And one of the boundary objects that we started working on that we didn't originally have was something from industrial and civil engineering called the concept of operations, which is a whole document, about how do we want the different agencies in the city to work together. And as we started working on it, more people started saying like, oh, well, but we need to talk to somebody else, and we need to also talk to somebody else. And then as new stakeholders came aboard, then the scope of the boundary object changed, as well as the role of it in the project. And so it had a very powerful influence on like everything.
Wow, and a lot of coordination, it seems. Like it just surfaced a lot of different needs for coordination.
Absolutely. A lot of new needs and a lot of existing needs that people haven't really thought much about. Yeah.
Wonderful. Thank you. Annelien.
Yes, well, actually, to keep it close to my profession, I think that my whole profession doing ethics research and ethics parallel research in technology is a boundary object. So everybody knows the concept of ethics, but all communities have different interpretations and conceptions of ethics. Everybody thinks it's important, but we use different classification systems, different normative approaches. There are also power structures are important, as became clear from Catherine's talk. Mm-hmm. So I use the approach of ethics parallel research also as a way of, as a boundary object in order to promote ethical innovation and ethical technologies.
Great. Thank you. And Nithya, do you want to go next?
Yeah, so my interests tend to be focused on communities in the global south. So oftentimes artifacts which are sort of taken for granted in the West have different meanings and different values and implementations for communities in the global south. So a couple of examples such as access to a device and notions around privacy can have very different manifestations. Say with device sharing that is so prominent in many communities, how we think about privacy and security can just be different for different communities around the world. So it's no longer just about online management of privacy, how apps and platforms manifest on one's device, which is shared with other members in that context, also rises into prominence, especially for women. Another example is of how affordances and communication mechanisms in apps and platforms that are quote unquote innocuous in the West can take on very different meanings and forms of abuse through cyber stalking and impersonation and just lead to devastating impact. The same knob or affordance can be used to cause harm to vulnerable communities. And we've shared this work with multiple teams at Google, and it's led to privacy and better measures for counter abuse.
I know that work. Yes, I'm very happy about that work. Catherine.
Sure. Yeah, thanks. Yeah, I think keeping with the theme of counter data from my presentation, I think one area that's super interesting is when counter data sets, in a sense, become more official data sets. And we sort of see this in the case of the Mexican data where the one person, Maria Salguero, has ended up collecting what is in a sense the most comprehensive public archive about feminicide. And so it's very interesting because while it's not a ground truth, and yet it represents the most comprehensive collection to date. And it's the one that folks can go to and access and so on as a way of tracking. So all these different people, NGOs, activists, families, have used her data set. She's even testified about it back to the state. So even the state is very interested in understanding her data set. It's like a very interesting phenomenon. And like, I guess I would make a parallel here to the COVID data collection situation in the United States, where we have a somewhat compromised national data collection effort happening because they've recently moved data collection from CDC to HHS. And so kind of who knows what's going on with federal COVID data right now. And yet, sort of who stepped into that gap is the New York Times and the COVID tracking project. And these have, in a sense, become some of the most authoritative sources, and yet they are counter data collection efforts. They're efforts that this institution is not required to do. They're coming from a kind of accountability and outside perspective. But I think it's really interesting when those become robust enough or comprehensive enough or long enough to start to be regarded as, in a sense, the most authoritative source. So I think there's this kind of interesting line that happens there for me. So.
Yeah, and picking up on that theme a little bit, I think you touched on something that I think is fascinating about boundary objects in general, which is just how concrete they are, or the process of getting to something more concrete, right? And I want to say physicality, but I think that's the wrong word, because a lot of these things are digital or are processes, and but just the fact that they exist as artifacts is incredibly important. And it becomes a catalyst, right? For the conversations, for the coordination. As you said, sometimes they're going to become the official things themselves. So my next question, Charlotte, is for you. I really liked how you talked about, the traditional boundary objects, which tend to be unproblematic or static, right? Or tend to be, not necessarily, but they're, I think, more well understood, if you will. And you contrasted that with the epistemic boundary objects, which themselves tend to evolve, right? And so when we think about something, now bringing those notions back to something like AI, when we think about, there's so many concepts that are still fluid and ambiguous. So things like machine learning fairness, the very definition is up for debate. And let alone whether or not we should be using if we should be using what metric we might or may not want to use. So in this sense, one of the takeaways I got from your presentation, but I'm very curious if you agree, is that when you have these boundary objects that are more fluid and they themselves are evolving, are up for debate, it seems like maybe these boundary objects are a little bit more fragile. I don't know, is that indeed the case? And if it is the case, is there a desire to move from this very fluid state to a more stable state? Or is that not necessarily progress? But I'm just curious, how do you measure progress, I guess, or
Yeah. I mean, I think it's really fascinating. And one of the things that, I hope folks will take away from, our conversation today is that the boundary objects sit within a bunch of practices and a bunch of communities and values. And so, to ask the question about whether a boundary object should be locked down is sort of a question about, should culture change or should organizations change? Or should people change? It's like, well, sometimes, sometimes a lot of times, right? And so, the question really is, what do we want to achieve? Do we want to achieve opening up a problem space, or do we want to achieve locking down a problem, right? And these two things go together, but when you're doing work, it can be like, well, at this moment in time where we want to do more generative work and a little bit of specifying, and other moments of time, we want to do more specifying and less generative work. You can think of a typical design process or a typical project. And then, over a long period of time, you're going to want to be going back and forth between these, right? And sometimes, depending on what's happening in the world, you may be forced to be in a generative state, or you may choose if you want to change structural relations. So the type of boundary object you want to foster depends on what you're trying to do at the moment. And I think, another, point to that is that depending on what you do, it's not usually going to be, sometimes it's going to be one boundary object that you're thinking about, or whether you're talking about epistemic or technical artifacts, opening or closing boundary objects. But oftentimes when you're doing anything complicated, you can break it down. So a boundary object can have boundary objects within it. Which, is annoying because it's more complicated, but it also gives you a lot more play to say, like, these parts I want to hold steady and these parts I want to like.
Nice.
Yeah.
Great. Thank you. Annelien, you have done extensive work in bioethics, in the bioethics sector. What are some of the proven boundary objects and best practices, if you will, in bioethics that you think we should consider adopting in AI?
Well, thank you. Well, actually, all artifacts that are used in medicine and all technologies that are adopted can be considered boundary objects. And I think a very recent example that I've been studying is the concept of organoids or organoids technology. And organoids are three-dimensional mini organs. It's a bunch of cells that mimics human organs, like a mini gut or a mini liver or mini brains. And we've been studying actually what actually is, from a conceptual point of view, an organoid, and does it have any moral status? Should it have legal status? And interesting enough, we have done extensive studies with different stakeholders. And there you could see that, for example, the researchers who are developing those organoids, which are made from tissue, stem cells from patients, they say, well, it's just a bunch of cells, and we use them, we multiply them, and we can sell them to companies and collaborate. And for them, they are an interesting tool to model human disease. On the other hand, the donors and patients that we've interviewed, they said, well, that it's a part of our body and our identity. It has our DNA, and it mimics, when we give pharmaceuticals to those organoids in a dish, it does the same as in our bodies. So they have a complete different conception of the organoid. And for example, the researchers say this is useful for personalized medicine, but they see personalized medicine also different from the patients who think with personalized medicine, it's about it's healthcare for them. And it's also interesting because in the end, we presented organoids as hybrids. They are neither objects or subjects. They have characteristics of both. They are both disentangled from the human body, but also entangled because they represent the body's DNA. And actually, by doing this analysis, we run a program for a couple of years in collaboration with the International Society for Stem Cell Research, and we were able to propose ethical guidelines for using and also distributing human organoids, because they are used worldwide in laboratories and companies worldwide. And I think this is an approach to, in the end, advance biomedicine, because I think that is everybody wants, but we don't want to exploit patients and donors.
This is fascinating, I have to say, the organoids. And it feels a little bit, I'm sure it's not the best analogy, but to me, it kind of feels like a simulation of a much more complex system, in a sense, because you don't have the entire body, as you said. It's separated, it's isolated. Yeah. But it's interesting, right? Because in a sense, it's data, it's information from the body, right?
True. Yes, that's true. And I think the how we now perceive the body as a source for with using wearables, with DNA sequencing, we can even make stem cells and gametes out of just human tissue. So I think the making a source out of a body is a very important object to study. Also, if you want responsible innovation in those fields. And I think there are many similarities with the development of AI, particularly in healthcare, but also in a broader sense. Because there we have actually exactly the same discussions. Now there are many AI-driven decision support systems, for example, in image-based medicine, where the pathologist and radiologist have discussion about what is expertise, because we were the persons who are doing a medical case and giving expert advice, but now we don't know that
an algorithm is more accurate in identifying, for example, tumors. But it's not accurate in feeling the narrative of the patient. So it's there we have there we're running a program about actually human or clinician and AI interaction, which is also fascinating.
Nice. Okay, I want to come back to that if we have time. Thank you, Catherine. You, I thought that the counter data set example is a very impressive one, and so one of the things I'm curious about is, in practice, how do you think counter data sets should start being used in machine learning? You know, in an ideal world, what are some of the specific applications that you think could benefit the most from this kind of much richer, more textured data that you spoke about?
Yeah, I think that's a great question. I think the thing that I would say would be more around not necessarily what knowledge we might get from using counter data sets, but maybe what knowledge we might get from collaborating with counter data collectors, I guess, in the sense that from what I've seen, generally speaking, and this is obviously not universally true, but I think a lot of times in technical communities, we like to collaborate. When we collaborate with experts, we collaborate with institutions, and there's a lot of like good reasons for that. But I think when institutions fail us, and I think they are failing us in many ways, when we think about racism, sexism, et cetera, these like long-standing, enduring problems of social inequality, this is when it's time to look to the folks who are doing the work in those areas and look to collaborating with them. And so I think that's where I think the most knowledge is to be gained, is in thinking about who do we collaborate with when we're building technologies, for whom are these systems, and how do we, so because in my opinion, a healthy democracy is a place that we make space for dissent, we make space for contestation. This is how things work, this is how things change. And so thinking about like what is the role of machine learning and AI in really fostering a healthy civic information ecosystem. So if we're thinking about like how do we foster the collection of counter data sets, the use of counter data sets by the people who are actually poised to like sort of use them, right? I think that would be maybe the question or the answer that I would say. So it's more a question of like whose expertise and position do we value, and how do we build stronger relationships with them and really kind of value the work that they're doing, not only from the standpoint of whatever the issue is, but also from the standpoint of like healthy information ecosystems, healthy accountability industries, basically.
Yeah, and sort of, as you said, like, what are the blind spots we don't even know we have? And it's going to be hard to figure that out if we don't broaden the set of stakeholders that we work with, or collaborators, as you said, right? Okay. Nithya, as you said, you've been working a lot of your work focuses on the global South. And as we know, these are not the communities that usually are involved from the start on a lot of the cutting edge work that is happening, right? And yet, a lot of times we also, as you showed in your presentation, depend on a lot of those communities to get a lot of the work done, especially around data collection. So I want to go back to data collection in a moment, but I am also very curious if you could say anything about the work, the nuances that you've been seeing affecting things like fairness and notions of machine learning fairness that are not, they're non-Western, if you will. They're not your mainstream, part of your mainstream conversation.
Great question, thanks. So taking a step back, right, the communities in the Global South, are today utilized to power the AI models that we're using all over the world, but are also increasingly attracting a lot of investment because they comprise a large technology user base, right? So both from the user side as well as the production and powering of these data sets and models. So fairness is actually really relevant to talk about here because there's been so much progress in the space of ML fairness, but predominantly centered in the West, right? So subgroups like race and gender, measurement scales like the Fitzpatrick scale, optimization techniques based on US civil laws. But fairness is highly contextual. We can't copy paste and apply it to everywhere in the world. And in fact, we are finding in our research that several of the assumptions made in conventional fairness can be inappropriate or even harmful to communities in India, which is where we've been focusing a lot. And that's because the distance between a model and a community is very large in a country like India because of distances of technical distance, of temporal distance, physical distance, emotional distance that come in the way of communities actually benefiting from these models. So simply optimizing fair model outputs can be a tokenism because the communities may never benefit from ML systems without the right mechanisms and safeguards. There's a few factors to consider here as to why some of these assumptions get challenged. One is that of data misses and distortions, right? So there is a notion in fairness that if we fix the data, we fix the bias. That data is actually representative of people and phenomena. But that's often not the case. For example, in India, half of the country is not online. So when you only have one half that's online, that's the privileged half that's online, it already skews towards specific communities. And the ML problems that are being worked on today are rather rich people problems, cancer and heart disease rather than tuberculosis, the poor people's problems. And we also see other factors, like there's a lot of human-mediated data collection, which I reference in the talk on the data collector and the rater parts. So there's a very rich human infrastructure, like community health workers, that are also used to collect data that powers ML data sets, in addition to their daily responsibilities of delivering healthcare to communities. And that, leads to different questions like, is consent to a health worker transitive to an ML model in the downstream uses of that data? We also see that, this assumption, which is so prevalent in tech, of this one-to-one correspondence of user to a data point, that is, a data point is a faithful representation of a unique user, actually gets challenged because of practices like shared device usage. And proxies can take on different implementations, like a name is the most semantically meaningful proxy in India. It can represent caste, gender, religion, ethnicity, and class. And zip codes, for example, are heterogeneous. Right? You might have slum communities abutting with posh communities, and that's a little different from the West, where it's fairly homogeneous because of histories of redlining. So data, by examining data, we see that it's no longer a simplistic, faithful representation of
the people or the phenomena we're trying to capture. But there are also other factors that are important to consider in fairness. For example, recourse is very poor for communities of the global south, right? Because of all these distances. So when user bias is reported, it's not quite acted upon by ML research or by the ML industry. And finally, AI is so new in many parts of the world that many high stakes AI deployments are actually embraced often too early. It plays this aspirational role in economic development of different nations, right? We call AI, countries manufacturing AI superpowers. It's highly masculine space. In India, for example, there is a facial recognition service used in New Delhi, which has very low accuracy. There's one report that it has 1% accuracy, which is being used in implementation. So solutions may be adopted a little too early without having the right tools and mechanisms to be able to scrutinize these models. So we often see an end-to-end opacity, not just model explainability issues, but we don't know what the data sets are, what the model behavior is, what the inferences are. So we need a broader ecosystem as well as a set of tools to actually be able to understand the fairness impacts of these systems.
Okay, thank you. So I hate to say this, but we are running out of time, and I wanna do a very quick, if you're all are up for it, a very quick round of a call to action. So as we saw, there are many problems, all the way from who are we leaving out to even when we are counting things, we're counting things probably the wrong way. There are many challenges, shall we say. But I would love to turn our minds now to the future and sort of what is the hope for the future? I wanted to ask you each for what is your call to action? As you think about the need to do better, what kind of boundary object do you hope is in the future for the AI community? Charlotte, please go first.
Yeah, absolutely. I think there are many wonderful opportunities. I think going back to my comments about looking at the boundary objects that are for collaborative sense making is a huge opportunity. So when you think about, like choosing which training data sets to use, how to have open up a space for conversation so people can discuss how to tweak how the algorithms are functioning and whether they fit how the communities think. I think there's huge opportunities there to open up the machine learning to this dialogue. It's just that we have to have those conversations in different places in the workflow than we did before.
Great, thank you. Catherine.
Yeah, thanks. I was really appreciating what Nithya was saying, and it was making me think of, I read a great paper recently called Against Scale, and it was just making me think how some of our inherited assumptions in technology are really hobbling us from actually doing good work in the space. So my closing thought was just to say that, this is something we say in the book as well, but things like history and context matter so much more than things like size and scale. And these are, we inherit this idea that more data are better data, that we need to scale something immediately. So I think my call to action is to say, have the courage to work small and to integrate technologies appropriately in collaboration with folks. And then I don't think scaling is impossible, but we can scale with coalitions and with collective action that's sort of mutually beneficial rather than forcing scale on populations where it's not appropriate.
Thank you. Annelien.
My call for action, and that may not be surprising, would be to submit the development of machine learning and other digital technology to democratic scrutiny. Because if it's part of the legislative process, then you are guaranteed that there will be checks and balances, that minority views will be incorporated, that there will be a public or at least a political discussion about which values need to be integrated in machine learning and other technologies. And I think it should be part and subjected to the public domain. And a very short example was the development of the COVID-19 tracing app in the Netherlands. As a senator, I was the spokesperson for my political party, and we decided that it should be subjected to a law. So there is now a specific tracing app law in the Netherlands. And this is because there was a lot of, from the people, the public emphasized that they were afraid for a surveillance society where the public is surveying them when they are using the app. People were distrusting the collaboration with data companies who were facilitating actually the development of the app. The government was saying, oh, but we're doing the right thing because we are following the general data protection regulation. So a very formalistic answer. And there was a lot of discussion about what is an ethical app. And I think making a law of it was the right way to do. And now we have a law and we have an app, which actually works fine.
Wonderful. Thank you. Nithya.
My call to action is very much along the lines of Catherine, Charlotte, and Annelien. It is to examine the end-to-end impacts of AI systems, right? How AI systems are conceived, produced, appropriated, and contested. AI is flawed and imperfect, and the use of metrics like F1 score and accuracy do not actually capture the impacts that these systems have on people, on living beings. As I talk about in the data cascades work, the use of system level metrics do not actually correspond to how good the data is, or whether the data collection process was fair, or whether it can cause long-term harms to communities. And even if we have a 100% accurate system, these systems are impacting people's lives. And so we need to be constantly evaluating them and asking if we're disempowering people, if they're being used for surveillance, if communities have a chance to contest, and so on.
Okay. Well, thank you so much to the four of you for spending this time with us, for sharing your thoughts and your experience and your knowledge. I loved the panel. I learned a ton. And thank you. Thank you so much. Thank you for waking up early and staying with us throughout this.
Thanks for having us.
Thank you so much.
You're welcome. Thank you.
Pleasure.
Thanks. Okay, so everyone on the live stream, in about 15 minutes, maybe a little bit less because our panel went 5 minutes over. We're going to start the breakout sessions. So if you are in one of those breakout sessions, you should have gotten an email. So please, in about 15 minutes, that's when that is going to start. Next, I just wanted to remind you that the next panel is happening in Boston, and it's about objective functions as a boundary object. And it's being led by my colleague, Martin Wattenberg, and another amazing set of speakers. And then later on today, finishing our program, we have the third panel happening in Seattle, and it's going to focus on participatory ML boundary objects in practice. And that's going to be led by my colleague, Jess Holbrook. And next, please keep the conversation going. Here are some of the URLs where you can find more of PAIR's work. And the symposium recordings will be available on the YouTube channel as well. And next, that's it for me. Thank you very much for staying with us and watching. And please stay tuned for the rest of the day. Bye, everyone.
let's have a bit of fun till our downfall. My love, if you feel like I do right now, don't say you're on the run to the other side. My love, you say you wanna try, but you never do. Sugar, there's a reason why we lose. Baby, come on. You say you wanna try, but you never do. Sugar, there's a reason why we lose. You say you wanna cry, but you never do. Sugar, there's a reason why we lose. I remember what I said, spoken in the dead of night. We're through. I hear voices in my head saying that you were the one. Do you? So why does it hurt? I left you first, can't admit it to myself. But I guess I was wrong, knew the entire time. You were my dearly beloved. You were my dearly beloved. You were my dearly beloved. Can I do you? You would look into my eyes, saying that you never felt this good. Now I dream of better times, wishing I could hold you close again. So why does it hurt? I left you first, can't admit it to myself. But I guess I was wrong, knew the entire time. So why does it hurt? I left you first, can't admit it to myself. But I guess I was wrong, knew the entire time. You were my dearly beloved. 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 You were my dearly
We can come back.
But the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget. 'Cause I gave you my whole life, and instead you gave me nothing. And you left me here lonely. We can come back, but the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget that. But the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget.
Hold up.
Someone to forget.
Hold up.
But the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget. 'Cause I gave you my whole life, and instead you gave me nothing. And you left me here lonely. We can come back, but the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget that. But the time is done. I'm running to escape from your left on light. 'Cause I know your heart. Don't try looking for someone to forget.
Hold up.
Someone to forget.
Hold up.
Someone to forget.
Can I tell you a secret? Will you keep it to yourself? Let me tell you a secret. No, you'll never believe it. You can fight it all you want. You just have to receive it. And I promised I wouldn't. Yeah, I swore that I'd never tell. Nothing wrong with a little lie. We're just breathing and killing time. Got no reason to change our mind. Nothing wrong with a little lie. No one knows how we're doing, say we're feeling fine. No one knows all the corners and the back of your mind. No one knows how to love anymore, and I'm sure no one knows all the answers. No one knows how to love anymore, and I'm sure no one knows all the answers. Can I tell you a story? Can you keep it to yourself? Let me tell you a story. All the real happy endings, they don't live in fairy tales. It's the light in the morning. And I promised I wouldn't. Said I'd never ever tell. Nothing wrong with a little lie. We're just breathing and killing time. No reason to change our mind. Nothing wrong with a little lie. No one knows how we're doing, say we're feeling fine. No one knows all the corners at the back.
when I fall into you. Yeah. Never read between the lines, just follow what your heart is telling you. A fire burning bright is passion, a prisoner, but please don't set me loose. Cause I never felt such pressure, and you said you feel it too. Harder than those nights in summer when we fall. When we fall into each other. When I fall into you. Yeah. When I fall into you. Yeah. When I fall into you. When we fall. When I fall into you. Those nights, yeah. When I fall into you. When we fall. Yeah. When I fall into you. Yeah. When we fall into each other. When I fall into you. Yeah. Never read between the lines, just follow what your heart is telling you. A fire burning bright is passion, a prisoner, but please don't set me loose. Cause I never felt such pressure, and you said you feel it too. Harder than those nights in summer when we fall. When we fall into each other. When I fall into you. Yeah. When I fall into you.
Can I tell you a secret? Will you keep it to yourself? Let me tell you a secret. No, you'll never believe it. You can fight it all you want. You just have to receive it. And I promised I wouldn't. Yeah, I swore that I'd never tell. Nothing wrong with a little lie. We're just breathing and killing time. Got no reason to change our mind. Nothing wrong with a little lie. No one knows how we're doing, so we're feeling fine. No one knows all the corners and the backs of your mind. No one knows how to love anymore, and I'm sure no one knows all the answers. No one knows how to love anymore, and I'm sure no one knows all the answers. Can I tell you a story? Can you keep it to yourself? Let me tell you a story. All the real happy endings, they don't live in fairy tales. It's the light in the morning. And I promised I wouldn't. Said I'd never ever tell. Nothing wrong with a little lie. We're just breathing and killing time. No reason to change our mind. Nothing wrong with a little lie. No one knows how we're doing, say we're feeling fine. No one knows all the corners and the backs of your mind. No one knows how to love anymore, and I'm sure no one knows all the answers. No one knows how we're doing, say we're feeling fine. No one knows all the corners and the backs of your mind. No one knows how to love anymore, and I'm sure no one knows all the answers. No one knows how we're doing, say we're feeling fine. No one knows all the corners and the backs of your mind. No one knows how to love anymore, and I'm sure no one knows all the answers. So afraid of you, lying so far into. Yeah, I wanna know it. When here it seems like the hell. Yeah, I wanna know it. Now I'm feeling right. How could you leave to me? Down, please. Lights on me, I am in bed the whole line of pretty. I see the day of dancing, I remain, I'll be dead to you. Yeah, I wanna know it. When here it seems like the hell. Yeah, I wanna know it now. I'm feeling right. How could you leave to me? Stay down.
been feeling lonely. I've been feeling, staring at the pictures on the walls. Every time I see you with some other guy I see, I don't mind. But every time you start to walk away, emotions, all the color starts to fade. And every piece I need to feel complete. I miss the way you used to touch my skin. You're irreplaceable. Can't you see the pressure I've been under? Can't you see that I've been moving towards you? I am so miserable, I am so vulnerable now. She can't break bones into a million pieces, digging my grave wherever she pleases. She got me on my knees, she got me begging please. But every time you start to walk away, emotions, all the color starts to fade. And every piece I need to feel complete. I miss the way you used to touch my skin. You're irreplaceable. that simple. You try to make things seem so superficial, and I won't have it. Why are you lying? Acting like you're innocent, I see you trying to work your magic. And I know that I fell for it in the past, but now I'm stronger than I was before. Yeah, I know that I fell for it in the past, but now I'm stronger, stronger than I was before. Stronger than I was before. So what's the problem? I got mine, you got yours, everybody's got them. I'm just saying, for your information, you ain't gonna get an explanation. You won't. And I know that I fell for it in the past, but now I'm stronger than I was before. Yeah, I know that I fell for it in the past, but now I'm stronger, stronger than I was before. Stronger than I was before. I've been up for 3 nights. My eyes are bloodshot red. Damn, I wanna see the sunshine. It's getting to my head. One look in the mirror, don't like what I find. I know that somewhere in there there's a good guy, but he runs away at midnight. I'm sorry that I stole your car. Ain't got those tattoos on my arms that don't mean shit to me. Maybe you should pull the alarm, so I don't take you way too far. Die before I'm 23. I'm sorry, Mom. I'm sorry, Mom. I'm sorry, Mom. I'm sorry, Mom. My siblings are perfect and I wish I were the same. Making bad decisions, it should be my middle name. I love playing with fire, it's my favorite. Watch me burn my whole house down, not feel a thing. One look in the mirror, don't like what I find. I know that somewhere in there there's a good guy, but he runs away at midnight. I'm sorry that I stole your car. Ain't got those tattoos on my arms that don't mean shit to me. Maybe you should pull the alarm, so I don't take you way too far. Die before I'm 23. I'm sorry, Mom. I'm sorry, Mom. I'm sorry, Mom. I'm sorry, Mom.
Well, this is what happens when I'm out of my medicine. There's collateral damage. I gotta go.
I'm sorry that I stole your car.
Hello, welcome to the Boston session of the PAIR Symposium. I'm Martin Wattenberg. I'm a research scientist at Google and one of the co-founders of PAIR, and I'm delighted to be here today. So this is a virtual symposium, so let's get oriented. Next slide, please. This is, just to be clear, one of 3 sessions on live stream. There was a session in London that happened earlier today. This one is happening now. Our theme is exploring objective functions as boundary objects. And I'll explain a little bit about what that means in a moment. And then there's another session happening later today on Seattle time. Next slide. So for the Boston session, the agenda looks something like this. We're gonna welcome you. We're gonna do a little bit of housekeeping. We'll explain a little bit the theme of the session. There will then be lightning talks by our 3 fantastic panelists. And you'll notice that there's an ish in this schedule, and that's because I think we may actually finish the lightning talks a little bit before 11, and that's good, great. That's going to give us a little bit of extra time on our panel. The panel should wrap up at around 11:30, and then from 11:45 to 12:30 p.m., for those of you who have been signed up, there are breakout sessions where you can discuss in small groups. Next slide, please. I want to mention that there are captions available, and the link is listed in the YouTube live stream description, so you can find the link there. Next slide. So I also want to mention, and again, this is part of the virtual symposium experience, we're living in a unique time in history. There's a pandemic. Please take breaks. Don't push yourself if you experience, video fatigue. Obviously, it's fine to drop out. It almost doesn't need to be said, but I think it's good for us to recognize this. So with that, I would like to turn this over to Kristen Conrad in University Relations to say a few words.
Thank you so much, Martin. As he mentioned, my name is Kristen Conrad. I'm a program manager on the Google University Relations team. I just wanted to take a brief moment to familiarize you with the University Relations team. So I partnered with the PAIR leads to put on this symposium, and I just want to tell you a little bit more about University Relations. What we do, we help enable academic collaborations for Google research, manage and support the interface between academic research and research across Google, promote and support academic research in Google's areas of interest, and support the next generation of researchers. We do this for the general good and participating in the ecosystem of academic, industry, and government to create research results and impact that would not otherwise be possible, and to make the world a better place. This symposium and the research you all do is a great example of this. Some of the results of this are papers, open source code, data sets, supports for all researchers across Google. And if you would mind going to the next slide, we have a couple different programs across University Relations that offer bidirectional flow. Everything from external research funding to scientific exchange. That includes research workshops such as this one, and building the next generation of researchers. All of these lead to the great outcomes previously mentioned. If you wouldn't mind going to the next slide. And just to tell a little bit more about some of our programs, the Research Scholar Program aims to support early career faculty who are pursuing research in fields relevant to Google. Faculty must have their PhD within 7 years of submission, and applications are currently open for that program. We also have the Award for Inclusion in Research. It's a global program which recognizes and supports the academic research in computing or technology that addresses the needs of underrepresented groups. Our Visiting Researcher program allows various ways for Googlers to do research with faculty, postdocs, and industry researchers. The Explore CSR program collaborates with the university to motivate women to pursue graduate study and research within CS. If any of these would be a match for your needs, I encourage you to reach out to one of our Google researchers or myself. I have my information on the next slide. And you can feel free to email me, or more information is available on the symposium website. Martin, back to you.
Great. Okay, next slide, please. All right, I want to talk a little bit about the People plus AI research team and what we do. So, we look at what we do, essentially human-centered research and design, and we're trying to make people plus AI partnerships productive, enjoyable, and fair. Next slide. So the thing I would emphasize is it's a broad team in many respects. We're divided among many different continents, based many locations, and it includes a set of people who are highly multidisciplinary. We have engineers, we've got research scientists, we've got people from the user experience perspective, product managers, all sorts of types of people, and that's very much by design. We feel like this is essential to exploring this space. Next slide, please. So to describe a little bit more about what we do, we think about this in sort of three respects. So one thing, next slide, is that we conduct and we publish human AI interaction research. And we do this through papers. Please go to our website. We've got a lot of good stuff there that you can find. Next slide. We also create and launch open source tools and platforms. And the goal here is that we build a lot of systems, we try them out internally, but we don't just use them internally at Google. We try to make things public whenever we can. And we think that this is an important way to get ideas out there and get tools out there for people to use. And then finally, next slide, one of our big goals is to widen the circle of who can actually participate in the development of AI. That's sort of a key thing for us to do. And we're going to talk a little bit more about how we do that now. Next slide, please. In fact, that leads us to the theme of this session, which is boundary objects for participatory machine learning. That's basically the theme of this whole symposium. And I want to talk about what that means. So first of all, next slide, let's talk about participatory machine learning. The idea here is that ML is such an important technology and it affects so many people that it's critical that we have a wide set of people who can help in the development, the deployment, the monitoring it, thinking about it, and so forth. And we're certainly not the only people with this goal. I think it's a generally shared goal by many people. But it's hard. And one of the reasons it's hard is that it intrinsically means you need to have collaborations across people with different types of expertise and different levels of expertise. Now, luckily, we don't have to just start from scratch in thinking about how to make these collaborations happen. For one thing, sociologists have been on the case for a long time at looking at how these multidisciplinary collaborations work. And one of the key things, next slide, please, is something called a boundary object. So the idea is a boundary object is essentially a bridge between disciplines. It's an object that sits between different communities. It's something concrete, a specimen or a field note as described in this definition here, that's used in different ways by different communities and is a way for them to collaborate. Next slide. So in this session, there are many types of boundary objects. And in fact, we heard in the previous session in London about data, for example, as a boundary object. What I'd like to talk about in this section, and what our speakers will discuss, is objective functions as boundary objects. And I think this is a critical concept. So next slide, please. Let's talk about what we mean by an objective function. So machine learning essentially is done via the mathematical process of optimization. Someone somewhere writes down a mathematical function, and the system essentially tries to optimize this function. It's funny, one of the ways you can tell that this is an important concept is it has so many names. People talk about objective functions in the optimization literature, but you also hear people in different communities talk about loss functions, reward functions, fitness functions, and so forth. It's kind of a pick your metaphor situation. And it's not so much people in different communities are motivated by fear or greed or whatever, but there actually are nuances to these different ideas. But the point really is that we have a mathematical function that the system is trying to optimize. So let's talk about how these things can operate as boundary objects in practice. So next slide, please. So the good part is that this means that a machine learning system has an explicit, precise definition. It's written down of its actual goal. This is very unlike traditional software, where anyone who's ever encountered a pile of legacy code often knows, like, one of the big questions is, what is it even trying to do? In a sense, with a machine learning system, you actually do have, in some respects, a fairly concise description of what it's trying to do. That's the good. Okay, next slide, please. However, there's also the bad. The bad is that as concise as this definition is, as explicit as it is, it can be pretty messy in practice, because often the definition of the function, in fact, usually, it relies on a training data set. And so understanding the function means understanding a big data set at the very least. Another problem is that the math of what's written down may not align with what a human designer actually wanted. You know, it's always an approximation, a kind of proxy. And worse yet, because of the form in which it's written down, typically in code or maybe somewhere else as mathematical notation, it's not always intelligible to non-engineers. I mean, even engineers may have trouble too, but there's something about the language that makes it actually hard to understand. So that's the good and the bad. Next slide, please. But I do think there's something beautiful here, which is that this is kind of an under-recognized site for collaboration. And I think if we acknowledge the importance of objective functions as boundary objects, I think there really is a chance where we can start to understand the pitfalls. We can start to see opportunities for people collaborating and so forth. Okay, next slide. So, this leads to the question of what design looks like in a world where people are thinking about these objective functions. On the left, there's kind of the cliche traditionalist view of design as, maybe choosing color palettes. Obviously, the world is much more complicated than that in reality. That's a caricature. On the right, there's a mathematical function, and we could ask, well, are we asking designers to think about math? Next slide. The answer is maybe. But we definitely do not want design of these systems to be restricted for people who love equations, not at all. And this is exactly why this ultimately becomes sort of a problem of collaboration, participation, and really thinking about what is the right way to think about these functions in a way that multiple people with different levels of expertise and types of expertise can grapple with them and help design systems. So with that, I would like to introduce our speakers. We have 3 people today who are fantastically well qualified to talk about this. And I'm going to introduce them in order. Ed Chi is going to give our first talk. He's a principal scientist at Google Research. Margaret Mitchell, she's also in Google Research. She co-leads an ethical AI team. And Sendhil Mullainathan is, let's see, the Roman Family University Professor of Computation and Behavioral Sciences at the University of Chicago, and has, he's done extremely interesting work in many areas. So with that, I don't want to take any more time away from the speakers. So I'm going to, let them start to speak. But the one thing I want to say is that you can share your questions as we go, as you hear their talks. If interesting things occur to you, you can email this address, pairsymposium2020@google.com, and add your questions to the Dory, or the question and answer system that we use. I don't promise we'll get to every question in the panel, but hopefully we'll get to a few. And with that, I'd like to go over to our speakers.
Hello, everyone. Thank you to Martin for inviting me to give this lightning talk. I wanted to talk to you about my perspectives on essentially a twist on this loss function as a boundary object idea. My name is Ed, and I'm from the Brain SIR team here at Google. So why am I qualified to talk about this? Well, first of all, I was an HCI researcher with some connections into the CSCW community. And in particular, I did a lot of work in social computing. But since arriving at Google, my team actually have been working quite a bit on recommender system, notification systems, and classification systems, and have made more than 300 improvements across many different product surfaces here at Google. And in particular, my team has focused across these 4 different pillars: neural modeling, reinforcement learning, responsible ML and fairness, and as well as robustness techniques for ML systems. And these four pillars interact in very strategically important ways. I don't have the time to actually discuss them in detail, but I'd be happy to answer questions or discuss with you during the panel. Now, with that aside, I wanted to make 3 points around this idea of boundary objects. And the first one is this idea of objectives versus loss functions. Now, product and user objectives are indeed often translated into loss functions. And so the premise of the discussion that we have today certainly makes a lot of sense to me and is not lost on me. However, there are some complexities here, and of which I want to bring up 2. The first one that many of you may already know about is something called the Goodhart's law. And this is one little pesky problem is that oftentimes what we have found inside of Google is that whenever you propose a measure to be a target, indeed, it turns out that it often ceases to be a good measure. So here's a nice little illustration of this. If you measure people on the number of nails made, then what you might end up getting is thousands of teeny little nails that are not very useful to you. On the other hand, if you measure people based upon the weight of the nails that they're making, then you might end up getting a few giant, very heavy nails because that's the fastest way to create weighty nails. And then what happens is that those nails are probably not very useful to you as well. So this concept of Goodhart's law has been well known in the sociological and economic circles, and sometimes it's also referred to as Campbell's law. And there are subtle differences between the two, but the point is that metrics are pesky and they're difficult to work with for these reasons. The other point I wanted to make about loss functions as boundary objects is that oftentimes loss functions are actually situated within a wicked problem. Now, in case you're not familiar with this concept, the concept of a wicked problem is that it is a problem that is difficult or impossible to solve because of incompleteness or contradictory or changing requirements that are very dynamic and very difficult to recognize. It often refers to ideas or problems that cannot be fixed, perhaps, for example, in time, or where there's no single solution to these problems. And the wickedness here, by the way, doesn't refer to the fact that the problem is evil. It just refers to that the problem has a resistance to eventual resolution. So in fact, another definition to the problem is that the social complexity is so high around the problem that there's no deterministic stopping point. And because of these complex interdependencies, efforts to solve it becomes very problematic because it just continues to reveal other problems, kind of like peeling back an onion. So I want to illustrate this by examples that I know about. So for example, when you're building recommender systems, in the past, before say 5-6 years ago, a common technique would be just to simply optimize for a single objective. But when in fact, nowadays it's become much more common to actually solve for multiple and diverse set of objectives using neural architectures that look like this. So this is an actual architectural diagram that we presented as a recommender neural architecture in a RexSys paper. Now, these neural architectures are actually really interesting. Despite the fact that maybe perhaps some of you have not had any experience doing neural modeling, but even that diagram can kind of give you a sense of what's going on in the system, in that there are multiple objectives that you're trying to optimize at the same time. And this brings me to the second point I wanted to make about these neural architectures as boundary objects. These boundary objects are defined to be things that crosses community of practice. So that means that business owners, engineers, executives, as well as perhaps external researchers can look at these objects, these architectural diagrams, for example, or definitions of loss functions, and be able to understand them, to make sense of them. And the fact that they're plastic, meaning that you can actually make changes to them, that gives you that communicates the kind of improvements that you would like to make them objects that actually have a kind of design ability to it that enables communication, right? So Charlotte Lee has talked quite a bit about these kinds of boundary objects as negotiation artifacts in collaboration, and indeed these neural architecture diagrams and the neural architecture ideas essentially become those negotiation artifacts in our collaboration with business owners, users, and other key stakeholders. So I think this idea that boundary objects can be communication vehicles for different community practice indeed does play out. And importantly, the idea that these boundary objects does cross different community of practice, that product managers, business owners, and engineers and researchers can all use them to communicate with each other, is a very important concept that actually does work out in this setting. Now, what I showed you earlier is essentially an idea map, right? So a map that gives you an idea of how you might be able to change these architectures to further your goals, right? So maybe you can add additional tasks, or you can ask additional experts, or that you should be changing inputs instead of just thinking about the neural architecture. Now, it turns out that, of course, these neural architectures can be drawn at different scales, at different granularities, and so we can create different details for different actors or different communities of practitioners in the space. We can also make them extremely more detailed, so that engineers have specifications to get real understandings of how components interact with each other. So, for example, here is a more detailed diagram that we presented that shows how mixture of expert and an idea for a neural architecture can resolve task conflicts between multiple objectives, or to create these shallow towers to factorize bias and variance problems in the system. The third point I wanted to make is that neural architectures are combined with objective and loss functions are actually learning objects. Now, why am I mentioning that? Well, one of the things that I learned when I looked up the Wikipedia article on boundary objects is that there's this article by Anne Balsamo and one of her collaborators. I know Anne, so I'm referring to her, talking about that there are these boundary objects that are actually learning objects. In particular, she was talking about this in terms of a distributed collaborative course and how objects within that course turn into essentially pedagogical materials that can be easily annotated and modified and passed around. And more importantly, that these materials can evolve to archive the meaning of their use in particular situations. So in the context of a classroom, they will have a particular meaningfulness, but when you take them home and use them as part of your homework, they take on a different situation and a different meaningfulness. So I think of loss function and neural architecture diagrams in particular having some of these very similar capabilities. They do serve as pedagogical material to communicate for engineers to communicate with each other, and to business owners and product managers. And they are indeed easily annotated and modified, and they do evolve over time. And so from that perspective, it fits these definitions. So those are the 3 points I wanted to make, that business objectives or user objectives indeed can be translated into loss functions, but they're not singular, and that you need multiple objectives. And loss function is not enough, that you need neural architectures combined together with loss functions. In fact, it's loss functions is part of it. That together seems to form a kind of boundary object. And then finally, they're beyond boundary objects. They really combine together to form a kind of learning object. So perhaps I can summarize my entire point by a single thesis, which is that product objectives in systems like recommenders and notification systems and classification systems are not just summarized into these single loss functions. As an example, recommenders are actually dynamic wicked problems that are socially complex. And it's very, very difficult for us to say that, okay, we're done with designing these recommenders, because often they're just evolving social environment in which these recommenders live in. What this all implies is that what we need are learning objects, such as these neural architecture diagrams, that allow us and help us to archive and make sense of the evolving complex problem. Thank you very much.
Hi, I'm Margaret Mitchell. I'm a researcher at Google, and I'll be talking about some things I've learned developing machine learning models throughout my career. So we often like to conceptualize and think of a machine learning pipeline as containing 4 basic steps, where training data are collected, a model is trained, media can then be put through some post-processing step, and then people will see the output. But before we even begin the process, the data itself encodes a subset of human perspectives, right? So when people choose to talk about things, That is their skew towards what to talk about. Data is not a snapshot of everything and all experiences for all of humanity. It's a very limited subset with all kinds of skews reflecting the way people represent themselves in that data. So the bias has a ripple effect throughout the rest of model development, as the data for training itself is by definition the only information that a model can learn from. And that's not even addressing the human decisions in what data to collect and how it is annotated, which further injects human decisions and human skews. More kinds of biases are then injected into model development by the choice of model, the choice of objective function, how the model is evaluated. And the choices, therefore, persist in the rest of the model life cycle. Human biases are further injected into any post-processing decisions or a lack of post-processing. And finally, once a model is deployed, people see the output and begin to act on that output. But as people act on the output, they are themselves creating more data based on that limited subset of data that is now made available from the model. So this then creates an echo chamber or feedback loop where the model then learns on the human data that has already encoded the biases in the first model decisions. So this can amplify problematic decisions over time. And I like to call this bias laundering. So one of the main ideas of this talk and in model development generally to keep in mind is that the choice of data set defines what we care about for the model. The default approach to handling representation in data is to simply use the training data that's available in a specific data set, evaluate on the evaluation data that's available, often with very similar distributions to the training data set. And this carries with it the value judgment that the representation of individuals in the data set is the representation that should be there for the goals of the model. So if critical aspects of the problem space are not represented in the data, then using the data out of the box means you are making the value judgment that these aspects should not be represented. For example, if a population is over or underrepresented in the data, and that leads to the selection of a model that performs worse on a possibly different subpopulation, then the implicit value judgment is that the model should perform worse on that subpopulation. If the data and training creates models that disproportionately underperform on some populations, then you're making the value judgment that some populations should receive worse performance. So one of the most important and simplest things we can do in this space is to think about the benefits and risks for different model errors in context. So for example, in classification systems, we can think about the error space following this basic breakdown of a confusion matrix where things either exist or they don't. A model predicts they exist or they don't. It can get these things right or it can get these things wrong. So something exists and it's not predicted is a false negative. Something doesn't exist and is predicted is a false positive. And these metrics are not all created equal, right? So in some cases, a false negative can be much more problematic given the foreseeable use of the model in contexts. So for example, privacy in images, a false negative can lead to something not being blurred, which could lead to something like identity theft. False negatives might be better than false positives in something like spam filtering, where if you get a job offer or a letter from a loved one, and this is filtered out as spam, you can miss something really important. But note here that the usage and context really matters. So if foreseeable users include those that are easily scammed, leading to a loss of wealth, then false negatives have greater risk, and model development needs to balance the different populations in determining the optimal models. So one of the themes here, when we think about the ethical development of models, one of the most critical components is foresight. Who are the intended users and who are the foreseeable users? What are the model goals and what are the foreseeable harms from different model errors, right? Whatever you do results in an output, right? So I'm just an engineer doesn't quite fly. It doesn't actually mean anything other than that you're intentionally being ignorant about these different kinds of errors that you are creating in model development. So I want to bring in a case study. I was able to work on a coronavirus forecasting model, and there were all sorts of decisions we had to make there. So first off, what to predict, cases, deaths, etc. How to measure the quality of imperfect predictions, using things like what time span should we be using in a forecast, A, to forecast, and B, to measure errors, how to group populations in the predictions, such as county level, state level, things like that, and also whether or not to model the effect of interventions or the effect of the forecast itself on changing the behavior of the virus. So common metrics in forecasting and in machine learning more broadly include things like mean absolute error, mean squared error, and then variations thereof. But notice here that these are all absolute values, right? So under prediction and over prediction aren't distinguished as part of model training. So this is, these are metrics that correspond to things like L1 loss or L2 loss. But what this misses is that drastically different effects of over-predicting cases and under-predicting cases are at play. So if there are false positives for case counts, and the prediction is that there will be more cases than there are, then the organizations and people using the forecast will be over-prepared. But a false negative in under-predicting case counts can create situations where there are less resources than necessary, and ultimately something like more death, right? So although both errors have pros and cons, false negatives are a foreseeable worse harm than false positives. So one of the punchlines here is that the I'm just an engineer approach inflicts foreseeable harm. This intentional ignorance is your value-laden choice. The goal in ethical model development is to make explicit the value-laden and normative decisions encoded in development with respect to the system usage in context. Development considerations include the choices of data, the model, the objective, how to evaluate. And usage, the considerations include the outcomes that the model may contribute to, including misuse and malicious use, with all kinds of different considerations, such as foreseeable harms, foreseeable discriminatory uses, and all the other reasonable side effects or direct effects of different model decisions. Okay, thank you.
Okay, let me start. What I want to talk today is about algorithms and how we interpret them, machine learning algorithms in particular, and I'm going to tell two stories. And these stories together, I think, will give us some guidance, hopefully, about this problem. The first story is not really work I've done. The first story is work that a Google team did a few years ago. So this was early days before there was a lot of work on machine learning algorithms applied to medicine. So there they said, we have a huge data set with x-rays, and in the x-rays we have labels on whether there's a problem. So they said, let's build a pathology detector. And so that was their goal with the project. And what they found, this is pretty early, they found remarkable success in this activity. And it was almost too good to be true. But they were like, well, this is really interesting, so let's go and have a look and see what the algorithm is seeing in the x-ray. So they applied attribution techniques of the kind that you're all probably familiar with, where we can see which pixels were most influential. So in doing this, they saw, okay, well, look, on this x-ray, this is where the algorithm is really noticing signal or picking up on signal. So why here? So let's kind of zoom in and adjust the contrast and say, wait, that's a little weird. That doesn't look like it's part of the lung. What is that? Well, it turns out that to be pen marks by the doctor. So what they thought was a pathology detector was actually a pen mark detector. Radiologists in the system from which the data came, when they looked at the x-ray and they saw something, they'd put a little pen mark on it. And so as a result, the algorithm learned to find pen marks. But of course, this is a disaster. You can't deploy an algorithm that was a pen mark detector to say, now we have a pathology detector. This is the kind of problem we all worry about when training machine learning algorithms, that instead of picking up the signal we want, it's picked up some other thing that's an artifact of the data set that's a confounder. This is why we have interpretability techniques at some basic level. In fact, I want to say this story is just a nice encapsulation for me of how we tend to normally and most often use interpretability, which is quite similar to how in another aspect of computer science what we tend to do, which is when we program, we tend to debug code. Similarly here, interpretability is being used to debug the machine learning pipeline, like problems in the data, things that aren't what we want. And since these algorithms are black boxes, we can't know what they're doing, so we use interpretability to try and get a handle on that to make sure they're doing what we want them to do, much like with traditional code. Okay, that's story one. Story two also involves x-rays, but this time it's about osteoarthritis. Osteoarthritis, for those of you who don't know, is a very painful degenerative condition, and in this case we're going to focus on the knee. It happens in many joints, but knee osteoarthritis is sort of the space between the bones, there's sort of lost cartilage and the meniscus is worn down, and so it's painful whenever you walk or move. So it's not a pleasant condition. And many people have this chronic condition. And the big consequence here is pain. Now, the story I want to tell about the pain is that it turns out that, well, here's how we measure it. We ask people suffering from osteoarthritis, tell us on the scale how much pain you have, and there's an official pain scale, Kuh's pain score. What researchers have found when looking at the pain experienced by those having osteoarthritis is that actually we find that the disadvantage in the United States, African Americans, low income, a lower education, experience much more pain, which is kind of tragic. They're sort of not just disadvantaged socioeconomically, but also physiologically, they're experiencing more pain by quite a bit. It's about 2/3 of a standard deviation by race. So why is this? Well, there are two theories, broadly speaking. Of course, there are many theories, as with all things. One theory says it's inside their knees. That's because of their lives, the disadvantaged have more physical ailments. So when they have, everyone had, who in the sample had osteoarthritis, but those who were disadvantaged had a more severe case of it. The other is that it's outside their knees, which is sort of non-knee related factors that might be driving this, life stress, etc. And this is also very tragic. It's that the conditions of poverty or disadvantage exaggerate physical pain. Of course, a very related view is it's not inside their knees. It's just, the survey measure is biased. But to me, there's two categories. Is there something in their knees versus is it something else is pretty big. So how do we get at this? Well, the way we would get at this is that we of course have one read of the problem, the pain score. Well, now we get the x-rays, let's get a clinician to look at the read, get a KL grade. That's the grade of osteoarthritis severity. And now ask, conditional on the KL grade, the severity of the osteoarthritis in the knee, is there still a pain gap? And what we tend to find is that in fact, even after you control for the severity that's on the x-axis here, you see that the gap barely changes. So by this data, people have said, wow, it's not a physiological problem, but something else, a psychological, sort of socioeconomic, or perhaps a measurement artifact. But is this really true? What did we actually do? We had a person look at the x-ray. I don't know, maybe there's stuff in the knee that the clinician didn't know to look for. I mean, medical knowledge is a limited thing that's still in flux. It's why we're still doing science. So let's instead have an algorithm look at the x-ray and predict pain directly. Now you'll notice, if there was something in the knee, the algorithm, given only the knee x-ray, ought to find it. If there's nothing in the knee, and it is psychological, given just the x-ray, it ought not to find it. So rather than conditioning on the KL grade, let's condition on this algorithmically generated thing. In fact, rather than relying on what doctors know to look for, let's ask an algorithm to look and see, is there some physiological correlate that you see in the knee about this? So Ironically, what we're using here is we're actually saying, let's use a machine learning algorithm to listen to what the patients are telling us, my knee hurts, and try to isolate if there's something in the x-ray. So the input is image of both knees, and the output that the algorithm is trained on, the label, is the Kuss pain score in the knee. It's important here, only the knee is given. That is, we'll come back later, but it's not like the algorithm is able to reconstruct. We certainly aren't giving it any of the other variables, and such as race, education. We're only giving it the x-ray. And we'll deal with the possibility that the algorithm has somehow reconstructed these other variables. Okay, but the key is it only sees x-rays, doesn't have access to anything else. What we find here is that when we condition not on the doctor's score, but on the algorithmic prediction, that's on the right-hand side, the gap significantly diminishes. So while doctors don't see anything in the knee, algorithms definitely do. It's in their knees, which is what people have been telling us all along. And you can look at our paper, but we deal with all the obvious things. Is it image artifacts? Is the algorithm just predicting race somehow? A bunch of these things. What I want to do is to connect these two different stories back together. Both were about x-rays, both are going to involve interpretability, because now you're going to ask me, wait, what is the algorithm seeing? But what the algorithm is seeing in this second story is a different thing than in the first story. Let me tell you why. There are two different approaches. In the first story, we were having the algorithm predict the physician judgment. In the second story, we're having the algorithm predict the pain score. And in that difference, in that choice of label, is the entire story. When we predict KL grade, we're trying to automate human behavior. When we predict pain score, we're looking for things that we don't know about. When we're automating, interpretability is about debugging. We know what we want, just do it. When we're doing prediction, as this story just ended, we're like, wait, you found something I didn't know? Well, what did you find? Interpretability for discovery is a fundamentally different problem. So when we took the known interpretability techniques to apply it to this, it didn't produce much. Why? Because we don't exactly know what we're looking for. It's not a bug that we're looking for. As a result, interpretability for discovery is what I hope to encourage all of you is an interesting area to work on. It's much closer to visualization. It's kind of look at the data to learn. It involves feedback loops. I don't know, what is the algorithm saying? You're okay with low recall. Anything in the knee the algorithm saw, any new signal is useful. And this activity of interpretability, I think, has not had the kind of tools associated with it. Most of the tools that we tend to have are implicitly, though not explicitly, focused on finding flaws in the algorithms we have. So I hope to leave with these two stories as a call to action that this is a really interesting kind of interpretability to work on.
Terrific. I was delighted to see all of those talks. I think they set up our panel, I think, perfectly, in the sense that, what you saw from Ed was sort of really nice explanation of a fair amount of background, as well as some really interesting thoughts about things besides objective functions, but in the same orbit that can potentially be boundary objects we should think of as well. In Margaret's talk, I think we saw sort of like the pitfalls of not collaborating. And in fact, the importance of being very, very thoughtful about the fact that we should collaborate. As well as I think the really very important and concrete question of when you think about objective functions, it's not necessarily something that involves incredibly fancy math and a million, bells and whistles, but even the question of how you weight false positives versus false negatives is absolutely critical to the user experience and consequences of a system. And I think that's a really important example to keep in mind. And then I think Sendhil's sort of two stories were sort of a beautiful example of kind of a cautionary tale of why an objective function may not be what you think it is, and the fact that the data hides a lot of important detail, but also where we can go with this and how we can think about this in a way that is actually, I think, highly sort of productive and humane in many respects. So with that, one thing that I will say is that we're actually ahead of schedule a little bit here. I said that we would begin at 11-ish, but maybe this is a fact about virtual conferences. Sometimes they can actually go really fast because people are not walking around the room to get up on stage. And so with that, I think we're ready to start our panel. We have all panelists here. And again, I'm going to introduce them. We've got Sendhil Mullainathan from the University of Chicago, Ed Chi from Google Research, working on recommendation systems and many other things, and Margaret Mitchell on the ethical AI team. So with that, I would like to start and say one theme that I think ran across all of your talks, and which I think is very important here, is that you've all been in situations where there are people in very different roles working together on machine learning systems. Based on your experience, do you have any thoughts on the right way for people to communicate around objective functions? You don't necessarily, for example, want a user experience designer to have to know the esoterica around L1 versus L2 regularization. At the same time, there might be some things that are good for people on both sides, technical or however you frame it, to know. And I'd love to get your sense of, from your experience or things you've seen, what are important ways that we can communicate across boundaries?
If I may start, I think one of the things that I often think about these kinds of systems from the perspective of something called it, we, I. So meaning the pronouns, right? And it refers to procedures, and we meaning the social, and I meaning what's my role in the context. And my experience in working on ML systems is that most of the time people actually understand very little about their role in the entire system. So for example, a product designer or product manager might have some thoughts about how the product should function, but it's actually has a real hard time communicating those ideas to either executive sponsors or to engineers who might implement them, and might even have difficulty in discussing whether those ideas are even plausible or workable or can be implemented, or whether the data even exists. And engineers often also have ideas, whether they're value latent or they're not value sensitive, as Meg was mentioning, or not. Even if they were value sensitive in thinking about their design, they may also not necessarily know about their communication role within the system. Is it really a responsibility to actually speak up, to actually expose their ideas? And if they do, what are the consequences of that? And so sometimes it's just simply that the procedure for communication is not well known or not followed. And other times is actually just the social connections are very weak within the team. And so it turns out very important issues in DEI, like psych safety, etc., are also very important, therefore, for those roles to become visible and actually productive. And so the team performance becomes, therefore, extremely important for realizing a good outcome, good in quotes. Let me use the air quotes.
I guess I can speak to this as well. So one thing that I've found that I think is relevant here is that everyone has a different role to play, and there's often people who are very good at translating across different disciplines and making, boiling things down from something that's very mathematical to something that is just relatively intuitive. That's not everyone, right? And not everyone should be required to do that, but we all have different strengths. And just as some people prefer to, always say covariate, sometimes you need to say it's a variable in order to kind of like make these, simplifying things, but make them understood across, even if one person really has this view of how to think about it, one person has this view of how to think about it. But as long as you can kind of appreciate that there there are people who can play these roles of translation across, that oftentimes people who are naive about it ask the hardest questions. Some of the most like, oh no moments in my life have been like telling people what I do at a party, and then they like ask some question and I'm like, how did I never even think of that? So it's just really important to recognize like all these different strengths that people are bringing to the table, and just really support that everyone knows what they're talking about within their realm of expertise, and really leverage that.
Let me add one thing. You were asking Martin also about like sort of techniques that might work. One of the techniques, maybe we haven't tried this yet, but we're starting to figure out how to try it. So maybe I'm inviting guinea pigs. One of the techniques that we've been focusing a little bit on is that the mental model I think people have is one of trying to get to a consensus description. And in a way, I think that mental model is obviously right. We need consensus, but I think it doesn't properly identify where the flaw is or where the weakness is. I think the weakness is not a lack of consensus. I think the weakness is better put as we have different languages describing the same object. And in those languages, we have a description. We may, in translating back to some common language, imagine we have consensus, but in our own private languages, we're actually saying very different things. So if you imagine there's a, let's call it domain description of the objective function. There is a data description of the objective function. It's got to get instantiated in very specific variables and SQL queries. And then there is a sort of mathematical definition of the objective function. So we've got these three different objects that are actually just in three different languages. And you don't know when we converge on English whether we actually are getting the translation back. So one of the things that I think could be interesting, and I suspect you all have better ways of doing this, but you know, there's these games you play at parties where someone writes something on a piece of paper, someone then draws it, then someone else writes what they see in the drawing, then someone else then, like, that's a game of like lost in translation. And I think something similar could be done here, which is, okay, you take my objective function, put it in a data set. Someone else who didn't hear what I thought the objective function was looks at the data instantiation and writes down what they think the objective function is. Someone then takes that, does the mathematical. I think it's finding those translational errors that I think could be the most useful thing.
That's, yeah, I really like that idea, and I like the idea of putting it into sort of a game-like form. I think that is fantastic, actually. I'm curious if one big question is, we've been talking so far about sort of designers of systems, people who are experts. Do you have any thoughts on how users, people who, like, let's just assume we don't want to require a lot of expertise or a lot of time, how we might get input from users, or even people are not using our system but perhaps otherwise affected by it, on the idea behind what our objective functions should be, or any comments on it?
I mean, this is where things like participatory design come in. Ideally, you bring in not only your target users, but people who will be affected by your system, and you walk them through the various things you do, and you ask them questions about it, what they fear, what they hope for. Again, this is a very translational exercise. You need to have people who are good about, taking the very fundamental sort of mathematical ideas and translating them to sort of, general sort of colloquial communication. But yeah, one of the answers there is bring the people in, all the different people who you think might be affected. This often means trying to go and gather people around the world who can weigh in. And, at a company like Google, maybe that's probably easier to do than at a university. But this is sort of the ideal, right? It's the participatory approach, where you bring in all the different foreseeable affected people and talk to them about what they're looking for.
Maybe I can go next and quickly jump in here with a small story. In roughly, I think 1991 or so, when I was just starting out as a graduate student, I was studying with a recommender systems professor. At the time, he didn't know that what he was building was a recommender systems John Ridler, my late PhD advisor. And he proposed to me these ideas about using Pearson correlations to gather a bunch of users' votes and ratings, and then use it to filter what was then known as Usenet news. And he proposed this, hey, maybe you want to work on this for your PhD. And I said, John, that's a stupid idea. You know, how are you going to get a bunch of people to rate a bunch of Usenet news sufficiently to tell you about their preferences, such that you can actually run your algorithm? I just, you know, from an HCI perspective, I never believed that he would get enough data. Later on, my complaint actually transitioned to something a little bit more nuanced. And this is maybe worth pondering as well, which is the continuation of the story is twofold. One is that what happened next actually was an interesting piece of work done by one of his other PhD students named Brad Miller, who said, it turns out that the implicit behaviors, you know, so for example, how much time you actually spent on reading the Usenet News article was correlated with essentially their explicit rating of their interest in that particular article. Now, at that point, I told John, I was like, this is also going all wrong because users' implicit behavior may not necessarily match with their taste. In other words, how much time they spent is not necessarily how satisfied they are. And another reason I said, John, your idea is stupid, and you know, I'm not going to work on this. And in 1994, they published one of the most well-cited CSCW papers of all times on collaborative filtering. And that paper and the subsequent system eventually won the ACM Software System Award. That was the second part of the story. And so in a way, I never worked on recommender systems until I came to Google. And so in a way, this is a story about why you should never follow my advice, because it turns out that I made some very terrible choices early in my career. But it is also an interesting story in terms of Martin's question here, which is what role should users have in their participation in the design of a recommender system, for example? Is it that they give input implicitly through their behavior? Is it that they should give explicit ratings? It turns out right at the formation, even before the first paper was published in the area, I have fundamental misgivings about some of these challenges. And even now, nearly 30 years later, we're still struggling with the same questions. So I guess, you know, with apologies to my now deceased PhD advisor, I guess I was at least half right.
Let me pick up on a couple of the threads that were said already. This may seem a little bit of a distraction, but just tell a little story too, which is when you see anyone sit down at Google Earth for the first time, or Google Maps, I guess these things have been around for a while. I'm old enough to see people see it for the first time. It's always telling what they first look at. Like, you have like the ability to look at the Earth from anywhere. Like, the first thing people look at is like their own house. Like, people are endlessly fascinated by themselves. And so one of the things that I think is a little bit underexploited is that when we ask people for feedback or inputs, it always strikes me as psychologically kind of astute, because people also like talking, but doesn't fully capture this intense interest people have in self. So, like, you know, what do we all do, like when we're in an elevator? We're like, look in the mirror, like we're like super, or we even on these calls, like you could look at anyone else, but you're like, find yourself looking at yourself. Why? You see yourself all the time. But so I've often wondered if there's a way we, instead of asking for feedback, say in the recommender system example, we could show the user what we understand them to be, kind of like create a mirror. Like, this is what we understand you to be. This is what we understand your preferences to be. So that there's something to react to, and there may be surprises to the user. Like, oh, I have been watching a lot of Korean drama pieces, like, you know, like, or whatever. Like, you know, I didn't even think about this, but that is me, and now I can, it has that reflexive piece, beyond just giving us objectives, it allows the user to introspect a little bit. It's got intrinsic value. But I've wondered if that's a way, or if anyone's seen something like that, where there's a way for us to kind of play back either your own data to yourself as a way of getting objectives, or perhaps a system. This is the system that we're designing. Is this the kind of system you want to be a part of? Or, you know, whatever that looks like. I think that would be interesting.
I mean, I guess I'll, if we're going on with discussing, like, I really agree with the last point you were making, but I also just kind of, in light of the topic of this whole event, I do want to sort of caution or flag that some people love talking and some people don't love talking.
Right.
Some people will look at themselves in the thing, in the video, and some people won't, right? Yeah. So it is the case that, you know, people think about themselves, but it's also thinking about themselves in context, which is a broader thing. And it is the case that people like to look at themselves, or people like to reflect on themselves in some way, but it's also the case that some people hate looking at themselves. Yeah. Talking, right? And so, like, in the spirit of sort of participation and speaking across you know, different mindsets, I think it is really important to realize that, like, a you-focused thing might be very useful for some people, but for some people it might really kind of turn them off. So just think that's useful to flag. But it's a really good point about, like, how to doing a mirror reflection sort of in order to get participation.
Building on what you're saying, I never watch my talks. I cannot stand the idea of seeing myself. So it's true, like, there is this aversion. We also interrupted. Go ahead.
I'll jump in by maybe invoking some of my interest in the past in HCI, since this very much about the user here. And there's two things I'm thinking about when Sendhil and Meg is talking about reflections or mirrors of ourselves. The first one, of course, is that this connects all the way back to early days of Greek mythology and philosophy of narcissists and Aphrodite and whatnots, right? But the other interesting connection to philosophy, or to sociology in general, of course, is also the work of Erwin Goffman on the presentation of everyday self. And here, what's interesting about that and how it connects to perhaps the story that I mentioned earlier of the difference between what is it that we think we do versus what is it that we do. And it connects to this concept of presentation of everyday self, because what Erwin Goffman basically said was that we have an ideal, essentially we kind of in a way have some idealized version of views of ourselves. And then there's kind of ourselves kind of existing within the social environment. And we choose to expose different facets to other people, kind of like on a stage when we're interacting with others. And so, interestingly, in recommender systems that are social versus not social. So, for example, whether your actions are being observed by other or not, people actually do behave differently, right? Like, you know, whether you thumb up something, if it's visible to others, versus not, actually is in a way predicted by if you want to think about it, you know, maybe connecting to things that Sendhil knows much more about than I do on game theory, for example, right? Your thinking about how you're going to present to others is going to be drastically different, whether your behavior is visible to others or even to yourself. I think that's where I'm kind of taking it this a little bit. Sendhil was kind of talking about just, can we give you some reflections of yourself, which is about the differences between your vision of your idealized self and what you actually do. And then there's the social aspect, which is, what is the idealized version of yourself that you believe you should present, and what you actually present, which is Erwin Goffman's point, as I understand it.
Conference calls and these sort of online things offer a really remarkable opportunity for, like, this activity, don't they? It's like, suddenly it would seem to me, from an organizational behavior point of view, there's this collective and individual behavior. And has anyone seen, I mean, even imagine there's just a tracker at the bottom that said, what fraction of the time have you talked? Is that like, it seems like there's a lot we could do in this space around this that would be, and it could just be private, only you see it, and you can enable it or not enable it, or, it's really, but have people seen attempts to do this? Because suddenly, our actual lives are digital in a way that they hadn't been 2 years ago.
It is interesting. I feel like there are definitely things that I've seen at various companies and organizations in the past that have done things. One thing that I remember noticing with a very old version of this is that people reacted in different ways. For example, some people might think, oh, if someone is shown talking a whole lot, they'll think to dial back. Other people are like, oh, good, I talked a whole lot. And it's very interesting. It makes you realize just how different everyone's viewpoints on these things are. One of the things that I think is really interesting that is coming up here is this idea of, this is all a very, there's feedback loops. It's a dynamical system in the sense that even as we provide feedback, whether it's liking something or these social aspects, there are these consequences, and it's not just a very simple function that we're looking at. We're looking at the function in context. And I think this relates to something Margaret was talking about, of foresight being important. And how can we have foresight with such complicated systems? Are there sort of ways that people are designing systems can think to look ahead? Is the most we can hope for very rapid hindsight? Should we think about monitoring instead? I'm curious to open this up to discussion.
I actually think what I'm going to say, Martin, you probably know a lot more about, so correct me if I'm wrong, but one really fascinating thing I learned about coming to Google was this idea of user journeys. And critical user journeys, where the idea is you think about different kinds of specific people who could be using your product or working with the system in some way, and what their full flow of interactions would be, what they'd be interested in and what they wouldn't be interested in, and then how things would evolve with them. So it really helps to ground on specific individuals. I mean, as we develop, we think about like generalities, like maybe we'll say like, this is this way for men, this way for women. But as soon as you start grounding on specific individuals, you can learn a lot more and understand a lot more about long-term effects specifically for this person. And so like there's this critical user journey idea, and then there's also, based on the sort of critical users that you have developed, you can also then speak to people who roughly correspond to that, to really understand specifically like what their experience would be, what they would be, and how they would use the system, what they would end up doing. And so, for example, I worked on a project where we had a lot of critical user journeys for engineers. We like mapped out our basic theory about how this all works, and like the kinds of things they would need to strengthen the work they were doing. And then we had interviews with engineers and just sort of talked through, we found people who kind of roughly corresponded to the engineers and developers who we thought might be using this, and then just, sat and had interviews with them to better understand, like, how is this going to affect your work? And so it's really, I mean, the point I'm making is that in order to have foresight, a very useful thing is to ground your thinking in individuals.
Building a little bit on that, I think once we've sort of grounded in the individual, build on something I mentioned around game theory. I think, we should never fool ourselves into thinking we're going to have foresight. Like, I think rapid hindsight is really, really important no matter what. But one of the things that can help us a little bit is, I think game theory is become this sort of highly mathematized field for no particular reason. Like the big ahas in game theory were actually quite beautiful, because what they were was they gave us a taxonomy of social interactions that was useful. Oh, like this type of situation looks like a prisoner's dilemma. This type of situation looks like a tragedy of the commons. This type of situation looks like coordination game of multiple equilibria. Like there are these paradigmatic kind of social interaction structures that we have. And I think at that level, game theory could be incredibly helpful, because once we've done what you're saying, Meg, and like gotten the individual perspective, now say, well, if those are the individual perspectives, does this look like a tragedy that comes? Does this look like a race to the bottom? Does this look like a signaling game? Like, and we can apply those, and you know, it's not always going to work. We're going to have errors, but we can be like, oh, if this is a signaling game, we know how those turn out. Like, everyone's going to like race to have the biggest car or the biggest house, or, you know, even if that. And so I think having some of those, I guess, you know, stereotypical games in mind, doing the ground up, as Meg is saying, and then trying to slot them in and say, do any of these look like they might resolve given the way I've designed the system? And so then maybe I should be moving it from a signaling game to something that looks more like a, you know, I think that could be kind of interesting.
And I'll jump in by, I think Sendhil and I should have coordinated better. He should provide a more positive view before I say my bit here, which is that, you know, obviously in the 10-minute that I got in the lightning talk, I spoke about wicked problems. And the nature of wicked problems that is so dynamical, or that the social understanding of it, or our ability to apply foresight to predict how the problem will shift over time, is actually very problematic. That's literally within the definition of wicked problems. And I think Sendhil has a lot of authority to speak to some of the interesting examples, challenges that we have found in these spaces. So for example, his work on cigarette taxes, or how the nature of corruption, how it works on obtaining driver licenses in India and whatnot, right? There are these very surprising results that come from it. And I think that's where it connects to Sendhil's point here about behavioral economics, which is that, you know, what we're hoping to do there, obviously, is using mathematical models to actually understand behavior, and to understand the incentive mechanism, and to understand the mechanism design. And, you know, essentially, these taxonomies of situations, as Sendhil was mentioning about it, you know, part of the work is finding holes in these theories when these game theories or mechanisms don't work the way that we expect them to. And the beauty of what we're seeing is, in a way, if you consider that to be beauty, in the sense of intellectually interesting beauty, not in the sense of that our mathematical theory or behavioral economic theories are broken, is that we find these very surprising examples. So it's not just that we have these taxonomies of situations, but we also have a catalog of things where they don't work. And we're like, why doesn't it work? Why is it not incentive aligned? You know, why is it not incentive compatible? And these seem to be wicked problems. Yeah, go ahead.
Oh, I was just saying, like, this is this frustrating moment of, but I have this beautiful theory and it all works together. So messing.
That's right. That's right. And I experience a lot of that, as you can imagine, in working on notification system, classification systems, and recommender systems, because, you know, in a way, the product designers and the executives are trying to write down physical laws of how these systems should work, and then we find surprising, oh, by the way, users don't want it that way. Oh, that's surprising. That doesn't match with my mental model of how they want the world to be. Now they change something, and then, oh, look at this. It's no longer incentively aligned either. So
I think the point that you're making here is, I think, so central. It's probably where we should have started, as you said, Ed, which is, at some deep level, there's an immense amount of humility you need in all of these systems, because it's not even at the level of, oh, it goes to scale and then it surprises you. It can go to scale, enter an equilibrium, things look one way, and then it surprises you years later. Because, you know, my favorite example of this is, it's amazing how poorly this example works, and it's a testament to human memory. All of us in 2012 had a very different view of social media. It was Arab Spring. It was the power of social media to unlock individual voices, unheard voices, democracy blooming. No one believes this, but we all thought this. Like we were 100% convinced the story of social media is the story of helping downtrodden masses rise up, right? I mean, even at that point, there was even at that point, some of the early stuff around citizen journalism, like, look, everyone will be able to take videos and expose corrupt. I mean, it was a pretty, so we thought we understood where that system equilibrated. And it, you know, that was a surprise then too. None of us anticipated Arab Spring. And then suddenly, like, look where the system equilibrated 3 years later. So it's kind of continued wickedness of the problem in these dynamical systems is something we just have to be super humble about, I think.
Yeah, I think that it's really good to keep that in mind, for sure. It's funny, it's like, you know, I think there is this tension as we look for things that a designer can do, but also, you're right, probably the absolute most important thing is to just realize the limits of our knowledge. And I think this is why, you know, being very observational about what's actually happening is important. It is interesting, you know, as you were talking before, I was thinking about combining something, you know, Margaret was saying about critical user journeys and the kind of game theoretical perspective. It's like, should we be thinking about critical group journeys, critical user games? You know, maybe there are these templates that we can start thinking that go beyond the individual, for sure. I'm curious, you know, one thing, maybe this is getting back to something a little too specific, but one thing I really liked in the lightning talks were some of the very good examples of things we should be thinking about. So this question about weighting false positives versus false negatives just comes up all the time. And I've seen many situations where people just weight them equally without even thinking that they should make that decision. Yeah. And I think this question about, say, label leakage, Sendhil, that you made, that you talked about, that's also really important. Do any of you have other examples you've seen of cases where, you know, either objective functions went wrong or were ignored in some way that you feel like, okay, that's something people should be aware of? Are there other, I don't want to get greedy for good examples, but I'd love to hear any, if any come to mind.
Well, one thing that might be kind of funny or fun to share is I was working on a dialogue system, and we were trying to use these deep learning methods to see if we could capture multiple interactions. Could we track state across multiple interactions and then have the system respond in a well-informed way in light of the conversation? But we were using, you know, like maximum likelihood estimation. So what is the most common, what is the easiest thing to say? Or what is the most common thing to say? And the system would just end up ending the conversation by saying, I don't know, I'm just me. Like over and over again. It just somehow picks this up that you can always say that in a conversation, and then you can end it. And so we actually had to think of another kind of objective, or like, how do we fit this in to actually diversify? And this is actually a problem that's come up again and again, like this difference between getting the majority and then diversifying in some way so that it's not always the kind of same thing. I had another experience similarly with vision to language systems, where we were learning from how people described sequences of events and trying to get descriptive stories from there. And we ended up at first with a system that would go like picture by picture and just go, this is awesome. This is awesome. Everything was awesome. It was awesome. Somehow learned that like people, when they're talking about pictures, often say, and it was awesome, or this was an awesome time. So it was just like, everything is, we called it the everything is awesome machine. So like, it's fun as a reflection of ourselves. Like we apparently tend to say awesome when we're talking about describing a bunch of images to tell a story. But it's also not exactly what we want if we're trying to make a system that sounds intelligent. So it's sort of interesting mismatch.
So you built a teenager and an 8-year-old. That's pretty good. We're getting up there. And I have an example from work we did last year where it's actually an algorithm at scale. This was a healthcare algorithm. And that example I always go back to because it takes us to where you started us off, Martin. It's around objective functions as well. So there the story was, here this was an algorithm to find patients in need of care. And the interesting part of the story is 6 different teams had built this algorithm. So there are 6 different versions of the algorithm and they all had the same problem. but yet it was at scale already. And what they did was they said, oh, let's find, using our data, the patients in greatest need for care. And so then they built it, predicted it, and then what we found was this huge racial bias. So conditional on the algorithm's ranking of how much care you need, you find Black patients are much sicker. So to end up at the same ranking by the algorithm, you would have had, there's these thresholds for who gets into these programs. You would have doubled the number of Blacks if you had cut by health rather than by the algorithm ranking. So huge gap. So where does it come from? And I think it comes from something, it's actually revealing about something important, which is in healthcare, we often talk about how sick someone is. But when that instantiates into the data, sometimes what we mean is physiological measures like blood pressure. Sometimes what we mean is, oh, how much care did you use? And those look similar, but actually one is, and they are for most purposes, but from the purpose of an algorithm, if you said, find people who end up using a lot of care, well, for the same level of health, Blacks have less access, so they end up using less care. So if you predict care usage, you end up with bias with respect to physiological health. If you predict physiological health, you get to more the right outcome. But there was this kind of miscommunication that's very subtle. It's not, you know, because the teams were very diverse, all six, some were nonprofit, some were for-profit, it's clear it has something to do with an ill-developed language for communication of these fairly specific objects that are quite brittle. That is, there are tons of research papers that talked about healthcare utilization costs. You know, everyone, we kind of understood, and when we as humans work with these, we know there's a little bit of a difference, and we adjust on the fly and we take care of it. But we have to be very literal when talking, you know, when putting it into a data frame and having an algorithm optimize against it. And something gets lost in that literalness. And we've seen quite a few examples, like that's probably the starkest, but quite a few examples of that variety where some literality is dropped, is infused into the system.
And I'll maybe jump in and thinking about this false positive question in a framing that connects again to my earlier point on wicked problems. When we think about false positive rates, or in psychology, a lot of times they talk about type 1, type 2 error, which I always get confused which one is type 1 and type 2. And then a little while ago, I decided I'm just going to keep repeating the whole day. The type 1 is false positive. Type 1 is false. And then I finally got it. You know, I hope for the rest of my life I won't forget that. But the reason why I'm bringing that up is really because false positive rates and these cost functions are indeed actually pretty counterintuitive a lot of times to people. And what's make them even more wicked, not in the sense of evil, but in the sense of difficult, it's also that it's really difficult for us to predict the feedback loop effects of how individual decisions kind of compound on each other. This is also another reason why poverty, for example, is really hard to eradicate, is because it's really hard to get people to think about compounding interests, both on the positive and the negative side. How do they get themselves out of terrible feedback loops? So I think I would like to broaden Martin's questions a little bit here to sort of not just thinking about individual decisions that we're making. And this is a point, again, you know, connecting to the game theoretical components of mechanical mechanism design, is that it's not a single term decisions that we worry about. It's loops of decisions that we worry about, and loops of false positive decisions, issues that we run into. And so, viewed from that perspective, I think what's even more damning about some of the challenges that we face, you know, going back to Meg's presentation or lightning talk about value laden decisions, and if you don't make decisions, what's your role in that feedback loop? What are we doing about the fact that technology is essentially a kind of amplifier, whether on the positive or the negative side? Social media, for example, you know, is maybe an amplifier for good in the case of Arab Spring, but an amplifier for bad when they're used to disseminate disinformation, for example. And so my main concern is really that feedback loop, the second derivative, the first or second derivative, if you will.
Great. Yeah. So we are approaching the end, and I would like to give you each like a chance to sort of, if there's any advice or call to action you would like to give to listeners. You know, I think there's both a very interesting opportunity here. I think there's important ways that we can work together. But one thing that is coming up, and I'm seeing this actually on questions, both on comments on Twitter and on our question and answer system, that there are also these big issues around translation, people talking about different things. And this has come up here, of course. And who gets to talk about these boundary objects. So I'm curious if, you know, just as give you a last chance before we close, just to say any last words of advice for people who are thinking about these systems or working on them.
Just because someone sounds really smart and confident doesn't mean that they're smarter than you.
Don't give away the game, Meg. We have yeah. That's great advice. So I'll go with one, which is I'll start with a confession. I had to look up what a boundary object was. And I'm starting with that confession because I think it's a real treat to learn stuff. And it really is very, very valuable. Like, I'll never understand boundary objects as well as you all do, but having learned a little bit of it helps me just be a little bit more bilingual. And I think my advice would just be, like, it's actually super fun to learn. And building on the last thing, it's learning a little bit. It's like learning a little bit of a language. And I would encourage you all to just like dabble and sample and learn from, because this is a time when we're going to need a lot more bilingualism. So.
Well, you know, this is it's interesting times this year, right? And everyone has had a rather difficult year. I'm in a particularly reflective mood. Usually this time of the year, first of all, it's partially because my birthday was very nearby. I think someone else on the panel might also have a birthday, if I'm not mistaken, but I don't want to out the person. But why am I bringing that up? Well, I think this year has been a wonderful, wonderful opportunity to do some self-reflection, both as individuals and also as groups and as a society. You know, maybe perhaps as my, unfortunately, age only increases monotonically, right? So as the years pile on, I become even more self-reflective every year at the end of the year. And I've come to the realization that the most important thing that we can do as individuals and as groups is use these self-reflective times to help ourselves to become better versions of ourselves. And to solve some of these wicked problems, whether we're using these boundary objects or not, we need to enlist the people around us to help us to become better versions of ourselves. And the systems that we build are simply reflections of our humanity. And so as a result, by creating better versions of ourselves, we'll create better systems. So, you know, I think Sendhil's point about learning here is important and poignant. You know, if we are continuing to learn, then there's progress. But if we're not learning, then there's no progress in building better versions of ourselves and the systems that we're in.
Terrific. Thank you very much. Thank you all very much. I personally have really enjoyed this conversation. It's just a treat to be able to listen to three people like you talk about these issues. So yeah, thank you so much for coming. I think with that, we're going to wrap up the panel. This is funny. I'm realizing there's normally a point where everyone applauds, and that's also something that is missing. But if you're at home listening, I hope you applaud. It's virtually. But the thing that I would like to say is that you can keep the conversation going. And let's see, I think there's even a slide that talks how we can do that next. So there are, there's social media hashtags you can use. Please continue talking with us. Most immediately, for those of you who have signed up, there are breakout sessions where you can talk about these, continue the conversation in small groups. And so with that, I basically just want to thank our speakers again. And wish you happy conversation.
Thank you.
All right, hello from Seattle, everyone, and welcome to the third and final session of our symposium today, which is on participatory ML boundary objects in practice. My name is Jess Holbrook. I'm one of the leads and co-founders of PAIR, and very glad that for everyone who's joining us. Next slide, please. All right, so like I said, we've had two really great sessions already. One in London led by Fernanda Viégas on exploring boundary objects in technology. And the second was in Boston with Martin Wattenberg on exploring objective functions as boundary objects. And our session here, I'm hosting from Seattle, is exploring participatory ML boundary objects in the field, in practice, in use already. If you missed either of the other sessions and you want to check them out and you're on the live stream, you can actually just rewind and go find it, and everything will be posted to our YouTube channel after our event. Next slide, please. So, captions are available at this link, but also probably the easiest way to do it is they're in the description in the YouTube channel right now. So if you would like to use captions, go ahead and click on the link. Next slide, please. And also just taking a moment, I don't need to explain to anyone what 2020 has been like. We've all been experiencing in our own ways. Please, if during any of this, if you're watching from home, you need to take a break, don't feel any guilt. Home and family comes first. About 10 minutes before this, I had to go do some area math with my 9-year-old, which I had to look up what that even meant and had to figure these things out. So, you know, we're all where we are. It's all okay. And please take care of yourself during any of this. Next slide, please. All right. And with that, I'm going to hand it over to Kristen from University Relations, one of our partners for this event, to talk a little bit about them.
Thank you so much, Jess. Hi, everyone. My name is Kristen Conrad. I'm a program manager on University Relations. I just wanted to take a quick minute to give a little bit of background about what University Relations is. For context, I helped partner with the PAIR leads to put on this symposium. And just high level, what University Relations is. You know, what we do, we help enable academic collaborations for Google Research, manage and support the interface between academic research and research across Google, promote and support academic research in Google's areas of interest. And we do this for the general good in participating in an ecosystem of academic, industry, and government to create research results and impact that would not otherwise be possible and make the world a better place. This symposium is, and all the research you do is a great example of that. Some of the results include papers, open source codes, data sets, and support all researchers across Google. Next slide, please. I just wanted to also share, we have a variety of different programs across University Relations which offer a lot of bilateral directional flow. Everything from scientific exchange, building the next generation of researchers, and all of this leads to, again, the great outcomes that I previously mentioned. Next slide, please. Some of the specific programs we have are the Research Scholar Program, which aims to support early career faculty in pursuing research in fields relevant to Google. The Award for Inclusion Research is a global program which recognizes and supports the academic research in computing and technology. We aim to support innovative research and working on positive societal initiatives. Visiting researcher, there's various ways for Google that can research with faculty, postdocs, and industry researchers, as well as explore CSR. It collaborates with universities to motivate women to pursue graduate study and research in CS. If any of these seem like it would be a match for your needs, feel free to reach out to me directly. My information is on the next slide, and we'll also have this available on the symposium website. So thank you so much, and back to you, Jess.
Thanks, Kristen. I appreciate it. Okay, next slide, please. So to set things up a little bit, I want to give everyone who might be just tuning into this session a brief overview of the People Plus AI Research Group, PAIR, and what we do. If you tuned into some of the previous sessions, apologies, some of this is going to sound a little familiar, but I think it's good context. So the People Plus AI Research team is a group that was started by myself, Fernanda, Viégas, and Martin Wattenberg a little over, well, depends on when you count it, but let's call it around 4 years ago. And it's dedicated to human-centered research and design to make People Plus AI partnerships productive, enjoyable, and fair. And if you want to learn about everything that we do, there's our website there. Next slide, please. We're a group that really brings together two disciplines that don't often work together in industry. So a lot of user experience and HCI, and then our machine learning and AI research scientists. We have all different kinds of roles on the team, but we really look at how do we find these interesting combinations between roles that don't often work together. We're also a fairly globally distributed team. So we have folks in Seattle, Mountain View, Cambridge, New York, Paris, Bangalore, and Accra, Ghana right now. And we hope that we actually increase the number of those cities and the number of people in those cities as the years go on. Next slide, please. And a lot of times we get asked, what does PAIR do? And so I like to say, PAIR does three things. So the first of which, next slide, please, is we conduct and publish human AI interaction research. That's the foundation of everything we do. We try to find out new things, and we try to publish that either in peer-reviewed academic journals or a few different popular channels. And we have outputs here, a couple examples around looking at things like word embeddings or our People Plus AI guidebook that we released last year. Next slide, please. Second, we're not satisfied with doing research and only publishing. And what we want to do is really enable people. And the way that you do that is by building things and creating tools and platforms. So we create and launch open source tools and platforms to build AI responsibly. One of the ways we look at things is, when people say, people who make AI or ML should do something, we find that should, and we go try to build something that turns that into a people can do that thing. So you can see a few of our projects here, like the What If tool, like the embedded projector that allow people to really inspect their data and model outputs, people who develop AI. Next slide, please. And the third thing is we really try to widen the circle of who can participate in the development and application of AI. So even everything I described right there is still a pretty narrow audience. Those are academic partners, those are developers who are already in the space. And so what we're trying to do is create a wider circle, a wider conversation, more participation. And we do that in a couple of different ways. So on the top is something that one of our teams that we partner with, a brilliant group of people called the Creative Lab at Google, worked on called Teachable Machine, which allows you to train an ML model in your browser locally, built on something called TensorFlow.js that was built by the PAIR team. We also published quite a bit on our Medium channel, and these range from kind of deep think pieces or a piece that might really challenge the way you think about machine learning or AI or who can be included, all the way to like some pretty fun just like Q&As or like what our team is reading. And this is just trying to bring more and more people into this conversation. So next slide, please. Throughout a lot of this work, we've, over the past year or so, really started to focus on the concept of boundary objects, and specifically boundary objects for participatory machine learning. So for some of you watching, that might seem pretty obvious or you get it, and for others, you're like, oh, great, what does that mean? Next slide, please. So it's framed in this idea of participatory machine learning, which is really a sub, we think of it as a sub or an application of the broader field of participatory research or participatory design, which is really aligned with our third, the third of the three things PAIR does, right? Broadening a set of people who can help shape AI and machine learning systems. And we're not the first people to talk about this. There have been some great researchers who have brought this up in the past, and so we try to think about what is our unique contribution. Next slide, please. And one of the things that we really focus on are what are the boundary objects of machine learning? Okay, but what are boundary objects? Boundary objects are a concept from sociology where such things like specimens or field notes or maps are used in different ways by different communities, but they bring people together. So that's the challenge is, can you create something that's an object, a model, an artifact that can allow two groups of people who couldn't really talk to each other in a productive way or an effective way before? This allows them to do that. And so that's what PAIR is really focused on, is how do we build more of these to facilitate more of these conversations and build AI in ML in a more responsible way. Next slide, please. So in this session, we're really going to look at participatory machine learning ML boundary objects in practice. So we've kind of looked at things from a theoretical point of view, and then Martin and his brilliant panel really zoomed in on objective functions as one particular thing to focus on. And so our panel is going to be our talks and panel are going to be all about people who have made something that has made contact with the real world, or people that aren't them or ML or AI developers, and really learn from what happened there. So we have a lot of different things that can be boundary objects. So you might say, okay, Jess, got it. Like, can you give me some examples? So there are many different ones that range from things that are critical elements of machine learning and AI and how it's developed. So you could have things like use cases are boundary objects. Can we agree on the purpose of this model or this product? Data, in many ways, is a boundary object. Objective functions, just the metrics of a system. What is it being optimized for and for whom? We'll see in our talks, art pieces can be boundary objects. They can facilitate conversations that couldn't happen any other way. Experiments in prototyping can be boundary objects. And we'll see in one of the talks about how really mapping systems and the causal nature of systems can be boundary objects, can facilitate. PAIR has put out a few different boundary objects in a lot of these different ways, where we have tools to inspect data like the What If tool or the language interpretability tool that are really for developers and data cards. We have things like publications like our People Plus AI guidebook and our AI Explorables that are meant to be pretty generally accessible and for people who are maybe not the developer building the AI or ML model. We have platforms and experiments that hopefully bring in new people who have never thought about machine learning or AI as a creative tool before. We have TensorFlow.js, we have the Bach Doodle and CoCoCo, and then interesting things like GANLab that allow people to really just kind of start to play with these things. And then of course, research papers, popular publications, and then we work with policymakers as well to help create the kinds of policies that are really going to encourage responsible AI development. And then, of course, events and these symposia are also a boundary object that help us have these conversations. So with that, we have a lot of these boundary objects in place already. But as we've been saying, it's incredibly important to look at all the different ways that we could create boundary objects and what kind of conversations those could facilitate. So next slide, please. So these are our speakers and panelists for this session. We're going to start with Donald Martin, and he's going to talk about causal maps and kind of trying to think about the social implications of a lot of these technologies and decisions and how we can facilitate those conversations. We have Anna Ridler, who's an artist in London, who's going to talk about data, and I like to think of it as almost the crafted approach to data and model building and what that teaches you about models. Mindy Dellicarpini, who is head of UX engineering for Search and Assistant at Google, going to talk about prototyping and the role that prototyping can play. And then Hanna Wallach, who's a senior principal researcher from Microsoft Research, is going to join us for the panel discussion to talk about all of her different work in this space. Next slide, please. All right. If you have questions along the way, if you have our Dory link from before, please use that. And if you don't, if you could just email pair-symposium-2020@google.com, and we'll add your questions to the Dory. And with that, we're going to get started with the first recorded talk. Sorry, all the talks are recorded. So we're going to start with the first recorded talk by Donald.
Hello, everyone. My name is Donald Martin. I'm a technical program manager at Google. The title of my lightning talk is Causal Maps as Boundary Objects for Understanding AI Development Territories. I want to start with a high-level assertion that to navigate the perils and promises of AI together, the tech and stakeholder communities need shared understandings of their respective causal theories about how the world works. Now, to navigate together requires a map. And a map is the quintessential boundary object as described in the seminal work by Starr and Grissomer about boundary objects. In it, they state that in natural history work, boundary objects are produced when sponsors, theorists, and amateurs collaborate to produce representations of nature. Among these objects are specimens, field notes, museums, and maps of particular territories. So what might be the territories of AI development? To explore that, let's look at an example of a major failure of an AI system. Many of you are familiar with the recently discovered racial bias in a medical algorithm that is widely used throughout the US healthcare system. The purpose of the system that the algorithm was a part of was to identify patients with the most complex healthcare needs. The idea being that this would reduce the overall cost in the healthcare system. Unfortunately, people not selected for the special programs by the algorithm suffered from nearly 50,000 more chronic diseases than those selected. And the people not selected were disproportionately Black Americans. So how did this happen? The researchers who studied the algorithm and how it was created identified that the root cause of this failure was the target variable selection decision that took place during problem formulation. Now, let's explore how these kind of decisions are made to introduce this concept of AI development territories. Now, problem formulation happens within what we're calling Territory 1. And within Territory 1, finance, sales, marketing, and product management people are making critical decisions about which problems to focus on, what the key factors of those problems are, and who the impacted stakeholders are. Decisions made in Territory 1 can have a significant impact on decisions made in Territory 2. In territory 2, you have software engineers and data scientists making critical decisions about data selection, model design, and training and testing. Territory 2 actually creates the main artifact we talk about in AI, which is the model or algorithm. And when we work on mitigating bias in machine learning, we typically spend most of our time focusing on territory 2. But as we discovered when we examined the racially biased medical algorithm, the origins of that bias actually took place in territory 1. So when we overly focus on territory 2 at the expense of examining territory 1, it can lead to us missing critical sources of bias that can have devastating downstream impacts. Now, mentioning devastating downstream impacts brings us to territory 3. Territory 3 is civil society, which suffers from the negative impacts of machine learning models when they exhibit bias. Territory 3 consists of citizens and policymakers and competitors and communities who are also making critical decisions about which problems they want to focus on, what the critical factors of those problems are, who the impacted stakeholders are, and what they're going to do to design and implement solutions to those problems. Now, I've talked a lot about decision-making because decision-making is the main activity that takes place in these territories. And as humans, we use our causal inference capabilities to make decisions. Those causal inferences are shaped by strong top-down prior knowledge in the form of intuitive theories. We call those intuitive theories causal theories, and we develop those over time as we gain experience navigating complex realities. Now, when we look at our territories of ML and AI development, realize that the key features of these territories are many different, independent, unique models and causal theories that key decision makers hold about the world and how it works. Now, each of these territories is like an independent island filled with many different conceptions of the problems to solve in the world and what the possible solutions might be to those problems. Now, there's not very much interaction or mutual awareness between these three territories, and that really lacks during the product development process. So it's not hard to understand why there can be mismatches in expectations and problem understanding that lead to harmful outcomes as a result of machine learning and AI development. Now let's take a closer look at what happened with the racially biased medical algorithm to drive home the point that there's a need to work on the problem of limited interaction and mutual awareness between these territories. Now, as a reminder, the problem that the designers and product managers were tasked with solving for this particular algorithm, the medical algorithm, was to select patients with the most complex healthcare needs for special programs. And within Territory 1, they formulated the causal theory that patients with the most complex healthcare needs would have spent more money on healthcare in the past. And this led them to select spending on healthcare as the target variable for the algorithm. Now, we know this was problematic and it led to racial bias in the algorithm. But why did that happen? That happened because this causal theory excludes critical factors that impact how much Black Americans spend on healthcare independent of healthcare need. These are factors such as underdiagnosis due to bias, lack of trust in the healthcare system, wealth and income disparities, and lack of access to affordable healthcare. These same factors taken together also lead to increased instances of complex healthcare needs in the Black American community while simultaneously decreasing how much they spend on healthcare. So there's a big disconnect between the conception of the problem in these two territories. And so this points out the need to bridge the gap between these two territories in terms of how they conceive the problem. There's a need for a boundary object to help do that. So our recommended solution is to introduce formal and explicit boundary object creation processes and methods to map these territories during the earliest stages of the traditional product development process. Now, these processes should be optimized to elicit, synthesize, and make explicit the causal theories of target and non-target stakeholders in these three territories. They should center the perspectives of the communities most vulnerable to algorithmic bias in participatory and non-extractive ways. And finally, they need to be able to contend with the dynamically complex nature of the societal context in which products will be deployed. Now, we've identified community-based system dynamics as a promising practice to operationalize these new methods. And we focused on that because the construction of boundary objects is central to the practice of community-based system dynamics. It's not an add-on. This is made clear based on this quote from the book, Community-Based System Dynamics. It states that the use of informal causal maps and formal models that can be simulated in system dynamics within a group model building session provides a systematic way to negotiate and socially construct a series of boundary objects. Now, we've been spending some time practicing system dynamics with stakeholders, and we introduced them to two main ways to represent causal theories using causal maps. The first is a causal loop diagram representation on the left-hand side. That allows you to express factors of problems and how they're related. I can't go into details about the notations, but that's one key representation for causal maps. The second is a stock and flow representation. This particular representation is optimized to be able to quantify the factors that are present in causal maps so that you can simulate them and gain a deeper understanding. Now, just to demonstrate that people can pick up the techniques for drawing these causal maps pretty quickly, I want to show you what it looks like in practice for people to do this work with a couple of photos. These folks are actually developing a boundary object about wealth and income disparities after only an hour and a half of introduction to the techniques. This is what it looks like in practice as well in terms of the sorts of boundary objects that are generated. These are key artifacts that help people gain a shared understanding of a complex problem. Finally, you can use software also to represent these causal maps to set them up for simulation. And there's also these software-based causal maps also serve as powerful boundary objects. So our next steps to kind of pursue this path of creating boundary objects and causal maps for bridging the gap between the territories of AI development are to, one, test the efficacy of CBSD in product development so we can identify the constraints of practicing CBSD in corporate environments in partnership with the communities. And then finally, most importantly, we want to focus on what it takes to build capacity within communities to fully participate and lead, because communities are typically the most vulnerable to the negative impacts of biased algorithms. Thank you for your time. I look forward to the discussion that we'll have in the panel.
Hi, my name is Anna Ridler. I am an artist and researcher based in London. His practice brings together loads of different things: technology, literature, sound, installation, photography, generative design, and kind of sits between the artistic, the scientific, and the academic. I've exhibited widely in places like the Barbican, the V&A, Pompidou Centre, had academic papers accepted at conferences like NeurIPS. I've been working recently around questions around predictive analysis, data mining, machine learning, and other advanced algorithms, and how they define the outlines of our lives as digital subjects, and how these things inevitably come to shape worldviews and social interactions. Amongst people who aren't expert in the field, there does seem to be a lack of understanding about how these processes work, and the need for a more open and understandable way of how data is used and collected and by whom. I try to examine the invisibilities of these systems through my work and hopefully open up ways of how people can start to understand them, and by this understanding hopefully try to change them. Because of this, working with data sets has become very important to my practice, and in particular ideas around classification. Data is, and not just data sets, but data. I'm incredibly interested in working with abstracts of collections of information or data, particularly self-generated data sets, to create new and unusual narratives in a variety of mediums. and how new technologies such as machine learning are using data in a dramatically different way. For me, it is very much a material that I work with. It's kind of a real kind of like a core part of my practice as an artist. I think to a lot of people, data can seem cold and sterile and algorithmic, but to me, it's an incredibly human thing. Each piece of data is a trace of someone's life, and it's this very messy thing that needs to be interpreted. And I find using an artistic practice is a way of doing this. And just to kind of briefly talk in this 10 minutes about how I approach kind of this way of working with data in an artistic practice, I'm going to talk through a project that took several years to make around speculation, labor, value, nature, and machine learning. This is still of an installation shot of one of the outcomes, which is a moving image piece, which I will talk about later. But I really want to kind of talk through how you can use data and machine learning, not just as a tool, but as a process and a way of understanding the world, and how you can use this kind of like using it in a creative way to explore the ethical implications of the technology, and also to kind of start to think about how these kind of ways of workings can allow you to do things that you never would have been able to do before. So to get to kind of this very kind of like lovely, clean installation shot of the piece, I spent a very long time coding everything up. So in addition to kind of like making the work, I also kind of do kind of back-end stuff as well. I think it's really important when you're working with these things to have a literacy of how they work, to be able to understand what each part of the code does and why, and to kind of build it yourself so that you understand where the kind of error states are coming from. You have a very intimate connection to kind of like your work and the outcome. And so for me, it's really important to kind of do this part of it myself. I do use kind of like code bases from GitHub, but I definitely modify and change them and draw together the things that I want to, in order to kind of get the kind of result that I desire. So a large part of any project is kind of doing this kind of like back-end work, this coding work. And I think you do kind of enter into a very different mindset when you're making in this way. You become very, very literal and kind of like, I feel it's like this real tension, because as an artist, when you're making work, you're trying to imbue stuff with as much nuance as possible. But when you're coding stuff up, you're trying to strip all nuance out and making everything super literal and super precise. So I think kind of creatively, there's this kind of this real tension in working in this way. And to make the specific piece that I showed here, where kind of like in this piece, it's a moving image piece and every still is generated using machine learning, using a GAN. So I had a very specific kind of aesthetic that I wanted to achieve, which really draws from Dutch still life and the flower on a black background. And because in the piece, I'll explain a little bit more later, but I wanted to be able to control to some extent the way the latent space, where the flowers were being formed. I had to not only kind of do all of this work, kind of creating the model, but I also had to create my own data set. When you're working with machine learning in creative practice, I really feel there are two main kind of things that you're working with. You're working with the algorithm, which has kind of certain kind of histories, connotations, associations, things that you can play with. And then you're also working with the data set. And there's a lot that you can do with the data set as a kind of, to kind of work with it and build with it. And to make this piece, because I couldn't just go onto Google and kind of ask to download 10,000 images of tulips with a black background, which are labeled in the precise way that I wanted them, I needed to make my own data set. So I took 10,000 photographs of tulips. Luckily, I was working in the Netherlands at this point, so the tulips were relatively cheap. And this process kind of forces me to examine each image and really kind of, I feel, inverts the usual process for creating a data set. Usually they're kind of, they're constructed using mechanical Turkers. They're usually constructed by at a huge scale. Like normally for data sets, you need millions and millions of images or inputs. They're usually kind of scraped from the internet or kind of very far removed from the person who then eventually builds the model. And so there's this kind of like always this kind of degrees of separation by these people who are constructing this data set. Like they don't own the image, they might not have never been to the place that they're kind of like working with. And for me, there's this huge difference, I feel, when you have that intimate connection to kind of like working with and kind of making the data set yourself. Sorry, just to go back to this, with all of the different flowers, there's this huge difference between kind of like pulling down 10,000 images from Google and taking those 10,000 photographs yourself. It's a very physical process. Tulips are kind of quite heavy, and it's very manual, kind of like stripping them and kind of constructing them and getting them to the kind of like to look how I wanted them. And you start to have this real kind of like noticing. You start to really examine each flower, looking for kind of like the different labels that you want to kind of apply to it. You start to kind of like really kind of understand kind of very subtle differences. And the process becomes almost like craft. It becomes very repetitive, time consuming, but necessary in order to produce something beautiful. And I think also, like craft, data sets tend to be unauthored. And I really feel that there is a skill to making a data set. Up until relatively recently, British copyright law kind of like included the idea of a data set as a literary work because it recognized this huge amount of skill that goes into making it. For me, I found like if I made it too big, if there were too many images, the results became very uninteresting, and the quirks and oddities that make machine learning an interesting to work with kind of disappeared. But if you make it too small, the model becomes flummoxed, either producing nothing or one or two variations from the training set again and again. And so it becomes this very iterative process of kind of working with, constructing the data set, seeing what will come out, changing what you're putting in, working in this very looping, iterative way that I found kind of like very kind of it really, again, it changes your mind. It changes the way that you're kind of observing the world, looking at the world. You start to kind of really notice things, and you become hypersensitive to, in my case, tulips. And it's a very kind of, as I say, physical process. It's really easy, I think, to overlook the labor that goes into making a data set and to ignore the network of human decisions that kind of go into machine learning, and how that data always starts out as objects in the real world before being abstracted and passed into an algorithm. And because such a large part of this project became making the data set, I wanted to make it into an artwork in and of itself, to draw attention to this labor and to kind of pay homage to kind of like the work and the time and the effort that goes into it. Normally kind of data sets that just exist just as zip files on someone's computer. But I really wanted to kind of bring this out. So the installation is thousands of photographs that are hung using tiny magnets in a grid. And each of the photographs has the labels, some of the labels that I eventually used in kind of when I kind of used the data set to build my machine learning model, things like color, things like what type of tulip, whether it's in bloom, dying, kind of a bud. And I decided to handwrite these labels onto the photographs, and that really was to kind of, again, draw attention to the fact that there are humans that kind of sit and are part of this kind of process that is, again, very easy to forget, that kind of like it's someone who has kind of like their own kind of like social, political biases sitting behind deciding what these things are, and how kind of like it's very easy to disagree with those labels. And even as I was writing some of them, I don't think you can see it on this installation shot, but sometimes I would cross it out because I would be changing my mind even as I was writing the labels on. Even for something as simple as a single type of flower, it's kind of very difficult to put things into binary categories. Like if something is red or if it is pink, if it's kind of like very pale yellow, or is it white? And you know, sometimes they'll be on boundaries and change, and like my labels will change according to the time of day, mood, or kind of what I'd seen before. And I think it's really important to understand this arbitrariness of kind of like some of these labelings, because they're encoded so far kind of behind. There's so many layers at the point of consumption of using kind of like machine learning algorithms, like on a phone or anywhere. There are so many layers that kind of like obscure this kind of like way that kind of people have decided that something is one thing and not another, that you don't always realize that when you're using these algorithms. And so part of this installation was to really draw that out. The installation in its entirety is 50 square meters. I think, again, it's very easy when you're kind of like scrolling through something on your computer, or kind of looking at it as a zip file, to kind of not really understand what 1,000 images or 10,000 images really is. But if you're being presented presented with these images kind of laid out on a wall that is 50 square meters, you really start to comprehend aspects of data that you might not have understood before. I think it's really important to consider how information is physical. And again, kind of like how things that you see on a screen always kind of were at once kind of like once objects in the real world. And by placing these objects back into the real world, I think people can start to comprehend aspects of data that they might not have done before. And the kind of final thing that I wanted to say is that this, you know, this is a working object. This data set was a working object. I then used it to make the moving image piece that you kind of saw the installation shot of earlier. The moving image piece is called Mosaic Virus, and it draws historical parallels from tulip mania that swept across the Netherlands and Europe in the 1630s to the speculation that was going on around cryptocurrencies. And in this video work that I made using a GAN, a generative adversarial network, which shows a tulip blooming to be kind of like this updated version of a Dutch still life. The appearance of the tulip is controlled by the price of Bitcoin. Mosaic is the name of the virus that caused stripes in the petal of a tulip that increased their desirability in the speculative boom and helped cause like the extremely high prices. At one point, a tulip bulb allegedly went for the same price as an Amsterdam townhouse before falling to the price of about an onion. And in this piece, the stripes kind of correspond to the price of Bitcoin. So the more stripy a tulip is, the higher the price of Bitcoin. And the tulips change over time to show how the market fluctuates. And I wanted to draw together, as I mentioned before, ideas around capitalism, value, and the tangible and intangible nature of speculation. And not only is it kind of drawing the connections between cryptocurrencies and tulip mania, but also the speculation that is kind of currently ongoing around machine learning and AI, because we're definitely in the middle of a hype cycle there. And kind of connect all of these moments in history and draw them together. But I was only able to do this because I feel of all of the work that I did building and unpacking the systems that I used. Thank you.
Hello, PAIR Symposium 2020. I'm Mindy Dellicarpini, and I'm the head of UX engineering for Search and Assistant at Google. Today, I'm going to be talking about why prototyping should be a key part of your machine learning product development process. But first, I'll briefly explain a little bit about what I do and how my discipline fits in. So, I am a UX engineer. Okay, what does that mean exactly? Well, UXers like myself use our strong technical skills to develop solutions to user-facing problems. Over the years, I've done this for a variety of companies, technologies, and design spaces, everything from websites to applications, operating systems, mobile devices, and a wide range of hardware platforms. Now, machine learning. Often UXC roles include creating prototypes, but I want to reiterate, prototypes do not just belong to UXCs. We have a broad audience here, so I'll describe a prototype for those not in the know. A prototype is an early version of a product or a feature built scrappily with the intention of gathering information, testing ideas, and answering questions. Here's the truly exciting part. The broad range of available prototyping tools and methods means this key part of the process is accessible to everyone on your team. Let's go deeper on why this is for machine learning for a moment. Remember, your systems are predictive and may change and hopefully improve over time. It's a much longer way of saying the outcomes are not 100% predictable, making prototyping all the more important for your products. All that aside, in my experience, the technologies are going to change, but the goal always remains the same: solve user problems. For that, it's important not to forget the user-centered design practices and tools that have worked before. Let me start out by laying some grounding principles I and my team adhere to when prototyping anything using a completely ridiculous product, the cookie detector. Cookie detector will answer with 100% certainty whether the cookie before you is oatmeal chocolate chip or oatmeal raisin. Clearly a top user issue of our time. We'll start out by saying the fidelity of the prototype should match the fidelity of the problem. While your questions and ideas are still broad, like, does anyone even find this valuable? Low fidelity options are going to be your best bet. Creating wireframes and lightweight prototypes using tools like ProtoPie, Figma, or even Paper can be your best place to start. Try a simple triptych here. User holding up the cookie detector app, pointing it at trays of cookies, receiving a result. Show it to your users and ask, hey, is this valuable? Once you start to solidify those ideas, and you've moved into things like, do users understand how to properly focus on the tray of cookies? That's when you want to increase the depth of your technical stack. So, we also like to say that even a failed prototype is going to be a success. In fact, this is part of why we make prototypes. Failing earlier, faster, and cheaper allows you to make those bad ideas go away or prove another path is going to be better. If a feature is going to take 6 months from research to design, that is 5 months too late to find out you were wrong about the product or the feature. In this case, congratulations, hero. You saved your company all that valuable time because you built a prototype to answer the very important question, does anyone even want a cookie detector? Finally, prototyping can be a great way to answer any number of questions, but before you dive into that deep end, you must know the question you're trying to answer. It can be as broad as, does anyone find this cookie detector useful? Or as tactical as, do users like the celebratory noise the cookie detector plays for chocolate chips? I know I would. Once you've got that question nailed down, you can start to gauge the fidelity and the tools you're going to need to answer it. With that last grounding principle, let me cleanly lead into the next part of the talk, a deeper and more serious dive into how prototypes have been used to answer the shoulds and coulds of product development with 2 real-life case studies. Let's start out with should we, since this is where your product journey should start. At this stage in the game, your goal is going to be to minimize the investment on your path to answers. Unfortunately, no one will ever come up and actually ask you, should we do this? And remember, defining that question is critical. I use should we as a placeholder for a range of questions you should be asking, like, does this product meet an actual user need? Does this work for different groups of people in different scenarios? Did you make any assumptions in your design, like a dependence on an internet connection? How about, do we expose any ethical issues or privacy sensitivities? Let's look at that case study for personalized recommendation experiments. Now, I don't have to tell you, creating systems that can give users personalized recommendation means developing a deep technical infrastructure, sophisticated machine learning models, carefully managed data sets, aka months and months of work. We already mentioned that would be bad because a ground rule is that you want to fail fast. Fear not though, there is a shortcut. Wizard of Oz is a super lightweight method used extensively by Google user experience engineers in which a real-life human working behind the scenes takes the place of that time-intensive system. In personalized recommendation experiments, user researchers can ask study participants to share information ahead of the study about their preferences. Then, we use that information to pre-populate prototype screens with optimal choices. My personal technology choices here are Firebase and update triggers with a nice vanilla JavaScript front end, but there are many methods that will let this work. Back to our study. Our wizard here would observe the choices a user speaks or chooses and react appropriately. Wait, they said blueberries. Quick, trigger that blueberries screen. And presto, instant personalization for interaction and product feedback on a high-fidelity interface with a low-fidelity technical personalization system answering the question of, should we? Moving along, I said there were two broad categories of questions, so here comes the second. In resource-constrained product development teams, and I think we can honestly say they all are, this set of questions is going to come after you've confirmed the direction is sound through early concept prototyping. Now, could we is going to come into play. This is my shorthand for open technical questions the team has to answer, including some that are very specific to machine learning, such as, can the team create a model that can reach the accuracy needed to meet the user need? Where did the data used to train the model come from? Are there any biases in that data that we need to mitigate? And what kinds of errors does the model typically make? Our case study here involves the AIY Project's Vision Kit. One of the demos the team wanted to include was an image classifier trained on the ImageNet dataset that was designed to identify 1,000 different types of objects. The demo involved pointing a camera at an object and returning a list of what the model guessed it was seeing. In the team's early testing of their hardware prototypes, they depended on off-the-shelf parts like a Raspberry Pi and a standard USB camera because, reminder, they started by identifying the key question to answer with their prototype, which was how does the image classifier perform? Building hardware devices from scratch was not key to the question, so this was an ideal place to take a shortcut. Back to our case study. What was the outcome? Well, the team found that while the model mostly performed well, it would also produce some interesting side effects. For instance, the model was convinced it had found a bobsled in a tech company meeting room. While these results were generally not problematic and non sequitur at worst and totally hilarious at best, it became clear that addressing this was going to be important for a good user experience. Luckily, the team was able to catch it early and fail fast. Now that we've examined those two case studies and some grounding principles, let's put it all together. What have we learned? Well, prototypes should be a part of any complete product development toolkit, including and especially one with a machine learning component. Prototypes are a valuable tool that can validate use cases and enable broader exploration. With a groundswell of tools available, prototyping is accessible to everyone on your team. Your prototype should always start with a question that you're trying to answer. From there, you can pick a tool chain and a technical fidelity. Prototypes make failing faster and cheaper and catch problems early for a better, more successful product experience. Oh, and one more thing. Beware of those lurking bobsleds. and avoid tricky oatmeal cookies. Thanks, everyone, and enjoy the symposium.
Excellent. All right, we are back. I hope everyone really enjoyed those talks. I don't know if I want to go bobsledding or eat cookies more, and usually it's always the latter. So really enjoyed that. I hope everyone at home did, or is watching at the live stream as well. It's the second time I've got to watch all those recorded talks. I took new notes this entire time as well. So now we are back with our panel. So we have Donald and Mindy here with us, and then joining us is Hanna Wallach from Microsoft. And I wanted to do just a little bit more of an intro for Hanna. So Hanna is a researcher who looks at fairness, accountability, transparency, and ethics. She's done so for quite some time. She also is the co-founder of two projects three really, to increase women's involvement in free and open source software, the Debian Women and the Gnome Women's Summer Outreach Program, now called Outreachy. And also is one of the co-founders of the Women in ML workshop and group. So welcoming Hanna and Donald and Mindy back. Welcome, everyone.
Hey.
So I'd like to kind of start us off, kind of getting into this place that one of the things I got from Anna's talk was I really liked the way that she phrased things about when she put up the pictures of the tulips of talking about placing things back into the world. Machine learning and AI tends to take something from the world and put it into a model, and this was really kind of putting it back into the world. And I think that that's really the theme of all of the talks that we have in this session, which is essentially what happens when we try to put these things back into the world, right? And so I think one of the things that popped out to me, and Donald, I'd like to kind of start with you and to get your thoughts on this of, one of the biggest challenges in building machine learning or AI systems seems to be the unstated assumptions by the builders. This was something that was actually touched on in the previous panel. And this often manifests as exclusion for different stakeholders and users or harmful consequences. So I'd like to hear a bit about maybe what have each of you found to help make some of these unstated assumptions explicit, or how do we get them out when people may not even realize they have them themselves?
Thanks, Jess. And again, thanks for having me on the panel. And it's been great to participate in this. So one of the things about unstated assumptions, I think it's important to be clear about what kinds of assumptions you're talking about. Because I think something that's really instrumental are causal assumptions. Those are these assumptions people make about like what causes what, and it's a conception of the problem that people are trying to solve, right? So people have in their mind, oh, this happened because of this. And that setup kind of leads your thinking in terms of how you want to solve the problem. This happened because of this. If I do this, this is going to solve the problem. And so those sorts of assumptions have all these kind of embedded stereotype and beliefs and values that can kind of lead to these biases that make their way further downstream, and they're hidden and they're hard to see. So it's really important to kind of like understand what kind of assumptions you're talking about. And I think the causal ones are really important. I think you pointed out that the exclusion, sometimes exclusion doesn't seem like, oh, someone got excluded, but it actually leads to real harms, like as the case with the racially biased medical algorithm. So lack of access to these programs, it's not hard to imagine that this could have led to people dying or losing income because they couldn't go to work, those sorts of things. And then the final piece, in terms of helping make things explicit, I think the first thing is just kind of awareness by stakeholders of how important their assumptions are in this overall system that is creating a new type of system. Like these are really instrumental factors in trying to understand the problem. And those assumptions are important. So just that awareness that these are like high stakes kind of decisions that are made based on these assumptions is important. That awareness. And then the second thing is making sure there's a safe environment for people to actually make their assumptions explicit. So sometimes when you're talking about these high stakes problems, you have to be really vulnerable to say, oh, I think this is causing that, or this is what I think about this group or this historical situation. And so, but if it's not safe, people are not actually going to be truthful, right, about what their actual assumptions are, and then that kind of defeats the purpose. And I think the final thing is important to actually have an actual methodology for going through this process of making these assumptions explicit, and a notation for representing them and making them legible. Because if you kind of do it in a ad hoc way, it kind of reduces the value. It's hard to reuse the knowledge later. So I think that's another kind of critical aspect, like a notation, a methodology, and that's what actually helps you create like a boundary object, right? That is plastic and reusable.
Yeah, definitely. Hanna, Mindy, any thoughts on this one?
Yeah, maybe I can jump in here. So I absolutely love Donald's talk. It really resonated with me. I spend a lot of time thinking about assumptions and worrying about assumptions. And a couple things I wanted to mention. So I think I'm coming at this from a slightly different methodology and notation and place, but I wanted to flag the framework of quantitative measurement modeling from the social sciences as a way of surfacing, making explicit, and then testing assumptions. So within the quantitative social sciences, people often want to measure unobservable theoretical constructs. So maybe it's something like ideology, maybe it's something like community membership, this kind of thing. And in the way that one typically does this is you posit a model for measuring whatever the construct is. But rather than just sort of make a bunch of assumptions, posit your model, build it, go off and run with it, before you actually go off and use that model, you assess first the reliability of the model. So are the measurements repeatable? But, and this is the point I wanted to get into, are the measurements doing what you think they are? In other words, what is the match between the theoretical construct and how you've operationalized it in a model? In other words, were your assumptions valid? And so when I was listening to Donald's talk, I kept coming back to these measurement modeling ideas from my own work. I have a paper with Abby Jacobs from University of Michigan on measurement and fairness that lays out some of these ideas in the context of fairness. And it really felt like Donald was talking about a lot of the same things that I've been thinking about there. We do make assumptions when we move from sort of the abstract theoretical kind of world into actually putting this stuff into models. And I think that example of operationalizing care needs as care costs, because care costs can be easily measured, is a great example of this. And so this is somewhere where we've found that that framework of construct validity can be really helpful for teasing apart, did we do this right? Did we get this wrong? And what are the consequences going to be? So there's 6 different types of construct validity. There's 2 that you would typically look at, and you would look at all of them. There's 2 I want to flag here. One is content validity. So did I get the content right? And that really is about those assumptions that I think Donald was talking about. The other one I want to flag, which relates to your comment, Jess, about putting things back into the world, is consequential validity. If I take my model with all these assumptions and the way that I've operationalized things and I use it in the real world, what are the consequences going to be? Who is going to be harmed by this? Who is going to benefit from this? So I think this is a different methodology, a different notation, a different framework to the one that Donald was talking about, but gets at many of these similar ideas as well. So I got very excited about all this.
That's excellent. That's excellent.
Do you mind if I just say a couple of things related to what Hanna was saying? I just love the way
it's a panel. It's a panel. Let's do it. Yeah.
I just love the way you framed that. And it wasn't kind of clear in what I presented, but this kind of quantitative aspect, one of the reasons that we kind of started to practice system dynamics is because there's a qualitative aspect and a quantitative aspect where you actually do get to the point where you're kind of measuring things and you're validating the hypothesis. So you create this kind of causal structure, right? You create this construct, and then you model it in a way where you can kind of quantify certain aspects of it. Hopefully you have data that's been measured already. And then you validate your hypothesis, right?
Yep.
And that's kind of the basis for actually trying interventions to try to understand the consequences, right? So simulation is like a key part of that whole methodology. And I think it gets at a lot for the same reasons that you described. So I'm looking forward to us chatting more after the panel.
Do you mind if I hop in with one more thought there?
Yeah.
As well.
What a polite panel. Yeah, of course. Hop in. Everybody go.
You said something about thinking about the consequences, and I think one of the exercises we do in UX is writing the headline. And I think this may also be very interesting, not just, you know, the best case scenario headline, but what are the worst case scenarios of what we could be putting into the world? And does that give people a voice for these concerns and to also talk about their assumptions?
I love that there. It's yeah, I think too, you know, Mindy, one of the things that's really interesting about the headline writing, and I wonder if this, some of the causal mapping and some of these others, is it, you know, there's a utility in maybe letting people be someone else, because it lets them step out of themselves and try to be the headline writer for this thing, or something like that. And then Hanna, I think your comments on the validity are really fascinating, because so as a social psychologist, you know, we've been going through the replication revolution, or the credibility revolution, or the replication crisis, depending on how you put it. But it's funny because in ML and AI, they have actually massive reproducibility challenges and problems as well. And I feel like they're almost just trying to figure out one form of validity, which is like this hyper contained experiment that can kind of run on, you know, a very contained benchmark, and then, you know, becomes quite brittle with contact with the real world, or any of the other kinds of validity that you would typically look at from a, you know, a scientific frame. That's a whole other panel, I feel like. So as not to commandeer, one of the other things that really stood out to me about the three of you is that every one of you is trying to design, you know, a boundary object or a conversation or understanding for a really diverse set of stakeholders. And I think this is one of the things that has been frankly challenging in the AI machine learning space, is how many people are involved in when you say we want to do it the right way. And so, you know, I think about things like, you know, creating boundary objects for users or end users, developers, policymakers, communities, like all these different groups. And really, a lot of times they have different and conflicting goals, right? It's one thing to write them down, and then sometimes you write them down and you realize nobody agrees, or they actually want the opposite things. So I'm really interested in maybe what you all have all found about, you know, the challenges or the tricks or the most challenging parts of this process. And Hanna, I was going to start with you on this one, because I also think you've kind of convened a lot of these groups, and you know, yeah, what do you do when people don't agree?
Yeah, this is a big one. I spend a lot of time wrestling with this one. And I think one of the things that stands out to me the most, I think I'm going to answer this in a little bit of a meta kind of way, but just with some things that popped into my head as you were asking that. Machine learning, so I've been doing machine learning for about 20 years at this point. So since way before this stuff was what it is today. And when I got into machine learning, it was this primarily, if not entirely, academic discipline, where the only stakeholders that you ever needed to interact with were other academics working in machine learning. And, you know, this is not the world that we're living in now. And I think it's only become clear within the past couple of years that the number of different types of stakeholders in machine learning is huge. It's basically every single person in society at this point. And that's a really, I guess, shocking and almost sobering position to be in, especially for many people who came into machine learning a long time ago, were used to just sort of primarily interacting with other machine learning people or other computer scientists, this kind of stuff, to suddenly be told, no, those aren't your stakeholders, you have to interact with all these other communities as well, is quite a daunting task. And I think in many ways, for me, this really feels like the public understanding of science crisis of our time. And I know it's dramatic to put it like that, but as I look around, I see so many people who are engaging with machine learning in so many different ways, including people who are making laws about machine learning, including people whose lives depend on machine learning. And yet in so many cases, folks from the machine learning community are not actually communicating, collaborating, and working with those people. And I think this is a public understanding of science crisis. I really do. I don't quite know what to do about it. This is the kind of thing that keeps me up at night. But I think it is something that the machine learning community really, really has to tackle head on. one of the things we've been thinking about a bunch at Microsoft is how do you communicate with, for example, customers of things like pre-trained APIs. So as you know, Microsoft has cognitive services, which is a bunch of pre-trained models that are available via APIs for people to use. How do you communicate with people, not necessarily the technical developers who are going to read the API documentation, but other stakeholders who might want to, let's say, commission systems that are going to be built on those APIs about their characteristics and limitations. And this is something we've been thinking about a lot. We've put out a few of these transparency notes at this point. You can think of transparency notes as being kind of similar to model cards that I know Google uses a lot of, that have a lot of details about model performance and stuff like that. Similarly, data sheets or data cards, as they're called at Google, which have information about data sets. Transparency notes are intended for a bit of a different audience and are really trying to capture those sort of characteristics and limitations. What should you use this API for and what shouldn't you? And these are the kinds of conversations that I think we really, really have to start having, because otherwise we're going to be in this situation with all these different stakeholders with conflicting goals and everybody just pretending that we're all on the same page, when in fact we're very much not. So I don't know, those are some of the things that I think about. I guess one other sentence I'll quickly throw in there. When you said different conflicting goals, I thought of this paper by Brent Mittelstadt. I think it's called Too Principled to Fail or something, that talks about the fact that when you have these like high-level responsible AI principles, everybody's like, yeah, fairness, yeah, transparency. They're all in on this because it all sounds very reasonable. But once you actually get into the details of what these things mean, once you get to that sort of nitty-gritty, that's where the disagreement starts. And that's where I think things get really interesting, but really hard. Anyway, I'll pause there. But
So Jess, I mean, I'll jump in because there's a couple of phrases that popped out at me. One is, disagreement is data. Disagreement is knowledge. Like the whole point of doing like group model building sessions is because you're trying to get at those conflicting goals, because those conflicting goals are driving the dynamics of the problems that you're trying to solve. So that's actually kind of gold, right? That disagreement and being able to kind of discover, what the landscape of disagreement is. That's the first thing. And then the second thing, Hanna was talking about the crisis of public understanding science. I actually think the crisis is science understanding the public. I think we should start thinking about it the other way, because you talked about how it's kind of daunting, right? For scientists to kind of think about all the stakeholders and all of society. And so this is why we wrote this paper called Extending the Abstraction Boundary for Machine Learning Development to include societal context, right? Because everyone knows, hey, we really need to understand the context of where we're going to deploy this system or this algorithm. That's critical. But people kind of stop there because it's so daunting, because you realize you have to think about all of society. You actually have to have some sort of way to kind of, grapple with that. You just can't walk away from that if you're really going to try to tackle fairness and ethical AI. And so it's daunting, but we really don't have a choice, right, based on the impact of these technologies. And it starts with us having to flip the responsibility for who needs to understand who, right? The crisis is science's ability to understand society and the public.
Catching on to a couple of those things, I think creating the proper kinds of artifacts is also helpful here. So for instance, I talked a lot about prototypes for user research and things, but they're also an excellent alignment tool. So you use it yourself and go, is this what we meant? Hand it to as many users as possible who are within your team, and understand as they walk through it, listen to how they're using it, listen to where they see the gaps. But I think that there's another interesting thing to think about here, which is, are there visual presentations that make sense to different groups of users? So if you're doing color extraction, does it mean building a very quick website to show, you put in this kind of image, these are the things that pop out? And again, these are more innocent examples, but the idea of thinking about tuning the presentation of the information to the audience it's for.
Maybe I can just jump in there about prototypes. So Mindy, I loved your talk as well. And actually it got me thinking back to when I first joined Microsoft as a researcher, and I was coming from academia, so I didn't have a lot of experience working with product teams. And I was collaborating with a couple of folks in MSR. We had some ideas that we thought could be really awesome, and we wanted to take them to product teams and get buy-in. And so we met with a lot of product teams, and we would tell them what we had in mind. And they would go, okay. And then we would go to the next one and tell them what we had in mind. And they would go, yeah, okay. And nothing came out of it. And so finally we thought, okay, this is just not going to work. We're going to build a prototype ourselves. And so we sat down and we built a prototype of what we had in mind. And we took that back to the product teams. We said, this is what we had in mind. You could see the light bulb going off. By working with a prototype, we were able to suddenly use that prototype as a way to make sure we were on the same page, to ground the conversation, to spark sort of directions off of it, none of which had happened without that prototype. And it really changed my thinking around this kind of these kinds of sort of collaboration opportunities, or maybe I guess I even mean communication opportunities, where you're just trying to see, do we want to collaborate? I just couldn't believe what a difference it made to actually have that prototype to ground those conversations. So I don't know, I got really excited about this idea of prototypes. I haven't been thinking about this for quite some time, but I got super excited when I heard your talk because it really resonated.
I think something else that's interesting about artifacts is it gives everyone something to almost throw stones at. See this? This is what we mean. Oh, but that's not what I meant. Or what about this? Or what about this other problem? Once you have an object, then people have to react to it. Just another reason you want to build these things as cheaply as possible, but also targeted at your audience. Hey, take this. What does this mean to you? What does this trigger in your brain?
Yep.
Yeah, I think. Oh, I was just going to say one thing. I think. I mean, what you just said, Mindy, really resonates with me because I think that it gets back to these boundary objects. Because what you're trying to do is you're trying to negotiate the boundaries. Like, what do you consider like part of the system? What do you actually consider the problem? What do you consider, what's kind of endogenous to the problem that you're trying to solve? And I can see how prototypes can help do that, because you kind of have you've actually kind of prototyped a solution to some sort of problem, and it helps expose your thinking about even what the problem is.
Yeah, it's Mindy, when you were talking, and Hanna as well, like it really connects to Donald's comment about disagreement is data. And prototypes allow you to disagree, right? So when Hannah's like, we went and showed them, and they were like, man, like the worst reaction you can get is that like, that's great, or whatever, the kind of non-reaction, because you'd rather somebody love it or hate it. But it's really hard to find that without the specifics, right?
And even in more of an academic context, but also in an industry context too, the other thing I found about prototypes is that, and I think this is just going to sound really obvious, but I'm going to say it anyway, if you can prototype using data of the person that you are prototyping this for, it makes it all the more real. When people see their own data, their own circumstances reflected in the prototype, that suddenly brings up a whole set of conversations that you don't have if you're doing this with some like abstract data. And so that's another way that I've really sort of, even if you're just sort of very lightly prototyping things, it's just another way of making this stuff real.
I could not even begin to agree more. I want to high five you, but we're on GVC. I touched on it a little bit. Yes, high fives. A little bit in the personalization prototypes, but it's not even just about that. When you show someone something, it's like, oh, check this out. It's about sports. And they look back at you and go, but I don't care about sports. You're eliciting a completely different response than if you decide ahead of time, music, recipes, cats, whatever it is. And then they can put themselves in the place of how they would react to it in reality. So it's very important to understand the question you're asking, but also the context of the user who's using that prototype, and therefore what kind of a response you're going to elicit.
Hey, one other thing that jumped in my mind is that of how important it is to also prototype the problem as well as prototype the solution, right? Because the kind of understanding of the problem is something that you need alignment on as well. And so that's another thing that the way we think about these artifacts you generate in the first part of SD, right? You're prototyping the problem, and it's visual, so people can look at your prototype of the problem and critique it and say, no, the problem is really this. And Hannah, you mentioned people's circumstances, right? This is exactly what you want to do. You want to be able to like be prototyping problems that are proximate to these folks, right? And get to the point where they can prototype them themselves, right? Build capacity so they can prototype the problems themselves. And that's the beginning of working towards solutions together.
These are great points. It makes me think of actually when I was at Microsoft almost 10 years ago, and we were building a Photos app. And it was the whole thing, even then, of having them bring in their photos, because, you know, you look at other people's, it's kind of like when you go to the frame store, right? And there's other people's families in there, you're like, yeah, it's fine. It's fine. And then as soon as people put their own in, they're like, you know, if you have one big image and a bunch of little images, they're like, why is the one big image? That should be my kid. Why wouldn't that be my kid? Like, and all of a sudden it's like an emotional reaction to this thing versus the like, it's fine. Yeah, sure. It looks good. The photos are all there.
Yeah. Donald, you said, oh, can I have one more thought? Sorry, Jess.
Yeah, of course.
Donald, you said something really interesting, which is about creating or prototyping the problem and prototyping the solution in that way. Another interesting approach I've seen is where users come in and sketch their solutions. And I think that's kind of interesting as well, because it's not just the problem, the people who are deeply within the problem space answering it, but they can sit down with pen and paper and go, it does this, and then it does this, and then it does this. And you get not only this idea of how does that person think the world works, but also what is an ideal outcome for them. And because it's just paper and pencil, completely accessible to everyone. You know, prototypes are not always code. They can be anything that can help you express the run through of your solution.
Yeah, I love that. And I when I was listening to you talk, I was just hearing the kind of causal aspect of this. It does this, and then it does this, and then it does this. Like, we're such kind of causal animals, and to be able to express, like, one, what you think is causing something, and one, how you think you can, you know, do something to cause that problem to go away, like, is just so embedded in this.
Yeah, those are great points. I remember too, we've done in the past, like, loan a designer. So like a designer will come out with us to like talk to people on like a visit and actually like basically like take a participant or somebody's ideas up a level of articulation. And one, it helps them articulate, and two, you know, people love it, right? Like, who wouldn't like their great idea, you know, articulated by somebody who kind of who's a, you know, a skilled professional in that craft. Actually hit on so many interesting topics in there. I think that, you know, in a sense, we've gotten a little bit about this, but I have one question here about some of the more, you know, Mindy, this was really, I wanted to start with you, which was, you know, some of the more surprising ways you've seen boundary objects increase participation. So not just, you know, they all kind of like can let it happen in some way, but increase it. And I think that we already kind of got on this, you know, in terms of the ML system definition. We haven't talked as much, it's interesting, we've been very at the beginning, we haven't talked as much about like the iterative process of like, okay, you're building something and you think you have a good idea and you realize you're changing it. And so the thing that stands out to me is the bobsleds, right? Is the like, how the mistakes can be so fascinating, right? And these range from, I think, you know, in the talks, we saw these range of the consequences of a mistake, right? Like Donald was talking about very serious mistakes. And then Mindy was kind of talking about like, you know, it's funny there. Oh, I thought there was a bobsled there. And like, how do we use mistakes or what are some of these surprising ways that we found that they can increase participation or have better conversations or whatever that might be?
Yeah, I think seeing the outcomes, even the mistakes, almost helps people to reframe their understanding of how a system works. So I think I was in a conversation yesterday where we saw, you know, a case where some subset of images, things worked really well for. In the other case, it was a different kind of images. And to someone not deeply in the machine learning world, of course, you know, they're images. Images are images. They should just work. It should be able to separate them from their backgrounds. But I think what it led to was a really interesting conversation around, well, why did this fail? What part of the conversation were we not involved in, and what questions did we not ask up front? Like, what were the data sets that this was trained upon? What were the, I guess, just the objective function? In this case, what were we trying? What was success for us? And it helped the team to really kind of converse around that and understand that they needed to be involved earlier and ask a different subset of questions versus just looking at the outputs and making some guesses about how it worked.
I mean, one thing that we discovered when we started to work with community organizers and advocates with system dynamics, it surprised me that these folks spend like decades thinking about a particular problem, but oftentimes they don't have a way to articulate the complexity of it, to communicate it. And so it's all in their head. And so once we gave them a way to like actually express this complexity and some of the hidden things like feedback loops and time delays, there was this big burden. They felt like this big burden off of their shoulders. They're like, finally, I can express how complex this is to someone other than me in a language that we both understand now. And then they just felt like, hey, I know these are huge problems, but it doesn't feel as hopeless because I can at least write it down and I can express the complexity. And so that kind of led to like more participation, and that ended up leading to us, doing a paper with some of these folks that had just started SD about healthcare and machine learning, right? And so this kind of removed this kind of even fear of engaging with this complex topic of machine learning, because they felt grounded in being able to express complexity. So that surprised me, that kind of the relief people felt just from being able to express that complexity.
Yeah, I guess maybe I want to jump in with just a couple thoughts on this one as well. I sort of got lost in a stream of thoughts over the past couple of minutes, because I think this idea of mistakes or errors as boundary objects is really powerful. Couple things I want to mention. Firstly, I learned about machine learning a million years ago when machine learning was done very differently. And the way that I would understand the models that I had developed was by doing serious error analysis, right? So for example, if I'm developing, let's say, a classifier, yeah, okay, I got all these things right, but what did it get wrong and why? And digging into every single mistake it would make would really, really help me understand the assumptions behind my model, how they were playing out in practice. So this ties back to the assumptions point, I think, that Donald was making earlier as well. And really see the models that I was developing, or even the training algorithms, whatever I was working on, in this whole new light. And so that whole notion of error analysis as being a really important part of the machine learning lifecycle is something that I think is critical and really needs to be made explicit. On top of that, I read a bunch of these NIST reports on facial identification and verification systems a couple years ago. And there was a piece in that, there was a sentence in there, I'm going to get this wrong, but there was a sentence in there that said, look, we are going to report error rates, not accuracy rates. And we're going to do this, one, because of the high 90s effect. People they just can't really perceive these differences between, whatever it is, 97 and 96. It's like, oh, whatever. Whereas when we're talking in error rates, which are much smaller numbers, these differences become more salient. On top of that, the human costs are proportional to errors. Right? So when we're thinking about the costs to humans and sort of the burden placed on humans by mistakes, that is proportional to the errors that these systems are making. And so by focusing on error rates rather than accuracy rates, we take this more sort of human-centered perspective. And I thought this was fascinating, and it really sort of reframed even how I think about reporting model results as well. But again, highlighting that importance of errors as being sort of a boundary object for different, bringing in all of these different communities, and the importance of errors in understanding the human impacts of systems.
Donald, I think you made a really interesting point that also linked with what Hanna was talking about. Interrogating errors matters. And as a machine learning practitioner, Hanna, you've done this a lot. Donald, in your case, it's about giving voice and giving vocabulary for discussing and having that conversation. And are there is there a way to tie these back together? Are there vocabularies that work better for certain groups, or does it depend on their goals? And how can we expose more of this language for productive conversations?
Yeah, Hannah got me thinking. Like I went to one of those states as well. I was like, because this linkage between the error of the kind of system, the ML system, the linkage between that and the cost to humans, it's not a straight, like there's some interpretation that has to happen, right? So I've got this error, but what does that actually translate into human cost? It takes this other, you have to go through this other, network of like assumptions, right? About like what impact this is going to have on somebody's real life, which is like, I think why, your hypothesis in the beginning of like what the problem is, right? Is something else that you might have to bring in. Because like, when you're doing testing of something, your testing should be based on your requirements in the beginning and your use cases in the beginning. And so, how can we get to where our error analysis is based on these assumptions we made about the problem in the beginning? I don't know how exactly that fleshes out, but it seems like there's something interesting there.
This relates to a discussion that took place at the FACT conference a couple of years ago. And again, I'm probably misremembering bits of it, so take everything I say with a grain of salt. But John Kleinberg gave a really interesting talk and talked a lot about abstraction. And then there was a discussion between him and Jen Wortman-Vaughan at the end, and they dug into this idea of abstraction as a thing that sort of computer scientists do. You go from this like messy real world, you sort of abstract to this nice, neat, kind of clean theoretical world. You then make a bunch of progress in your nice, neat, clean theoretical world. And the point that kept coming up was that then people forget to map this back to the messy world when they're talking about the benefits or the impacts or the errors, all of this stuff of what they've done. And so this, because I think it relates to measurement modeling and all of these other things I'm interested in, really stuck in my head of, we do as computer scientists put all this time into sort of abstracting from the real world into this beautiful theoretical framework, but abstract or, going in the opposite direction, whatever the opposite of abstracting is, going in the opposite direction back to that messy real world, people often forget to do that bit.
Yeah. Yeah, that reminds me of a quote from a paper. I'm not going to remember the authors, but it was a paper on problem formulation. And they had a line in there where they were talking about, because when you're to abstract, you're creating a model, right? And all models are wrong, some are useful. But this quote actually talked about how, you do violence, on the real world when you create these abstract models, right? You're doing some, actually doing some violence, right? Because you're simplifying things. And when you're doing that, those simplifications are where there's these risks for harm come in, right? And so that quote always sticks out with me in terms of like the high stakes of these early abstraction and modeling decisions that are being made, and they're being made based on these causal theories that we have in our head about how the world works. And if those assumptions aren't informed by a broader set of causal theories about how the world works, right, we're doing even more violence, right, when we're doing that modeling and that abstracting.
Yeah, I would say, and as always, the half hour flew by. But one thing that's really actually stood out to me in this last conversation is, what's fascinating is whether it's an accuracy rate or an error rate, it is treated as a constant. But when it is fed into a system, it can be multiplied, it can be fed into a feedback loop, it can be diminished. And Donald, I think this is with all these models, is like we tend to think about things as these constants that come out. If you build a prototype of it, all of a sudden you realize, oh, geez, that's right. That thing we thought would happen once actually happens 10 times, and they're not independent. The 10th time is as soon as you get to the 5th time, the 10th time is almost guaranteed at that point. And I feel like that's one of these, something that's really popping out. I don't know how many error rate tables or accuracy tables of like some soda paper where you're like, oh yeah, you did it, and then you're like, yeah, but what does that mean? Because you've isolated it outside of the system that can manipulate that value.
There's also these, I know we're talking about, there's also these kind of delayed impacts, right? So you do your measurement, right, and it hits the world, but the actual error, you don't realize it for like, another month, right? Because sometimes the feedback loops are slow. So the delayed impacts are something else that you have to kind of keep in mind. You may not see it right away.
All right. I'm trying to think of a way of how I don't have to stop the panel now, but I think we're out of time. This was really enjoyable. This like flew by. I could be here for quite a while. Hopefully we'll get to chat a little bit more. Thank you, all three of you, for participating in this. This was like genuine fun, which is just great. And I learned a lot. I hope you all do too. And I think with that, we'll wrap up the panel. And yeah, the next thing we have on the agenda, if you are signed up for one of the breakout sessions, they'll be starting in about 15 minutes, about 13 minutes right now. There was kind of unexpected demand and interest for those, so not everyone got in, but thank you if you expressed interest and you couldn't. This is the end of the live stream. Next session, or sorry, next slide, please. If you want to keep the conversation going on social media, we have the hashtag, there's our website, our Medium, and the YouTube channel, which has our previous symposia as well, which were excellent also, and they'll be up there. And yeah, next slide, please. And if you're not in a breakout session, it's kind of crazy, but that's it. We're done with this symposia again. And hopefully we will see you all next year. So thank you very much for everyone who tuned in. Bye.